Welcome everyone, this is another Chris Course with your host Chris, and today we are going to be coding. Your very first fighting game. We'll start off by learning how to code some basic fighting game mechanics. We're going to start off with some rectangles that know how to fight each other. Once we develop these fighting rectangles, then we're going to go ahead and change these rectangles into sprites with animation. We'll learn how to create sprites for both our background and our fighters, and then we'll touch up our interface design, making this game ready for live on the web. So without further ado, let's get started. So the first thing we're going to do is focus on project setup. This just means we're going to set up our folders, our files, pretty much everything we need to get up and running. So to do this, what I like doing is within Sublime Text, I like going to File, New File, and then I have a new file open. All I need to do now is hit Command S to save it. And now I need to go ahead and create a directory. So I'm going to go inside of a folder that is familiar to me, and that is a web directory that I created personally. And inside of here, I can go ahead and create a new folder, and I'm going to call this Fighting-Game. So with this new folder created, now I can go ahead and save this as index.html and hit save. We have our first file created. Great. So now inside of index.html, what kind of HTML element do we need to create a game? Well, no other than a canvas element. So we're going to go ahead and create that now. So once we have a canvas element in place, we can hit Command S, and we should be good to go in regards to opening this up within a browser. So to open this within a browser, we can go to Finder, and then go inside of our web directory, specifically the folder we just created, which is going to be fighting-game. And this is the file we just created, index.html. So all I need to do here is double click it. Now we have it opened up within a browser. So if I go ahead and inspect this element, by right clicking and hitting that Inspect Element tab, you'll see we have a canvas within our browser and all the HTML elements, which are pretty much put in there by default thanks to Chrome. So we have our canvas element within our HTML, but now we need a place in which we can actually write code. So we're going to create a JavaScript file to do that. Back in Sublime Text, we can go to File, New File. That's going to create a completely new file for us. Once we're here, we can hit Command S, and then we want to go ahead and create a new file within our fighting game folder called index.js. Then we're going to go ahead and hit save. And now we pretty much have all the files we need in order to get started with this game. It's that simple. So it's pretty useful to have both index.js and index.html open at the same time. So in order to do that, we're going to go to File, Open, and then we just want to go ahead and find the folder in which we want to open rather than one specific file. So once we have just this folder open, we don't need to click either of these. We can simply just hit open right here, and then we're going to see our project opens up. We have our folders on the left-hand side. Going to be a lot easier for game development if we have this open at all times. So let's go ahead and start by resizing our canvas so it's the correct size for our game. It's going to be 1024 by 576. I typically find that's a good ratio and size to make sure that our game fits on most computer screen sizes. So in order to do this, we're going to go inside of index.js, and we're going to go ahead and create a const called canvas. This is going to be equal to document.querySelector. We want to go ahead and select an element from this list over here, whether it be HTML, head, body, or canvas. Which element do we want to select? Well, simply the element that has a name of canvas. So all we're doing is grabbing canvas from right here and storing it within the const of canvas. Simple enough. The next thing we want to do is select our canvas context. This is what's going to be responsible for drawing out shapes and sprites onto our game, so it's important that we go ahead and pull this in. To pull in our context, we'll create a const, call it C, set it equal to our canvas const, and then we want to call a method on top of this called getContext. And then what kind of context do we want to get? A 2D context, 3D context, those are mainly our options. We want to go ahead and get a 2D context because we know this is going to be a 2D game, not a 3D game. So with 2D inside of here, we can go ahead and save. And now we have our two main consts ready to go, canvas and C. C just stands for context. And the reason we're calling this C is because we're going to be using this so much, it's going to be really tedious to keep calling something that's long. Typically, I never recommend creating variables that are just C or something really short like this, but this is the one exception I'll make. For canvas context, it is okay to call this C. So we have our canvas const and our C const, our context, but we want to go ahead and resize our canvas, and we're just going to use JavaScript to do this. I typically find CSS muddles things up a bit when creating canvas games, so we're just going to do it the standard way within JavaScript. We can do that by selecting our canvas const, and then we want to go ahead and select the width property on top of this. So once we go ahead and assign any value to this, whether it be 1000, 2000, we're basically just saying our canvas width is going to be equal to that amount of pixels. So a good value for width is going to be 1024. And then beneath this, we want to go ahead and select our canvas height as well, and declare that our height is going to be 576. This is a 16:9 ratio, and by having a width of 1024, we're going to make sure this fits on most screen sizes. So if we save this, go back to our browser, and refresh, we're not going to see any difference in our canvas size just yet, because after we go ahead and save index.js with all this code right here, we need to make sure that this is pulled into index.html. So right now we only have our canvas element, but when we're inside of here, we can also create a script tag that has a source equal to index.js. So I'll go ahead and type in index.js, save, go back to our browser, refresh, and then you can see our width and height are taking effect. I can hover over this. You'll see it's pretty much taking up the width of 1024, the height of 576. So we're pretty good to go in regards to the size of our canvas. If we want to go ahead and see the full width, we can always move our dev tools down by clicking these three icons right here, and then clicking this little tab icon, dock to bottom. That's going to move it to the bottom. I can hover over our canvas again, and you'll see that's how much width it actually takes up. Now, in order to see our canvas background, well, we need to be hovering over this canvas element down here to emit that blue highlight onto our screen. Let's go ahead and make it so our canvas has a white background by default, just so we can differentiate it from our actual browser background. So within index.js, we can go ahead and select our canvas context. This is what's used to draw shapes onto the screen. And once we have our canvas context, we can begin using the canvas API. So what is an API method that we can call to draw a white background? Well, we can call c.fillRect. We're going to create a big rectangle, and we're going to use it to fill up the entire width and height of the canvas. So fillRect takes 4 arguments. The first is going to be an x position. So if I go ahead and put the x position at 0, and then the second argument is going to be the y position. So I'm going to go ahead and assign that to 0 as well. All this means right here is to draw, starting from the very top left of our canvas. This is a coordinate of 0 and 0. Back over in our code, we want to add in a third and a fourth argument. So the third argument is going to be the rectangle's width. How large do we want to draw this? Well, we want to go ahead and draw this to full width of our canvas. So we'll go ahead and select our canvas width. And then for our fourth argument, we want to go ahead and put the height in there. So we'll say this is going to be a rectangle that takes up the full width and the full height of our canvas, which is assigned right here on lines 4 and 5. So let's go ahead and save this. We'll go back over here to our browser and refresh. And now we have a black background. So that actually takes care of the need to differentiate our canvas from the browser background. And I'm actually using a browser called Min. It's just a minimal browser that still uses Chrome DevTools. If I go ahead and close out of this, you'll see our background is white, but our canvas is black. That is totally fine to start. We know where our canvas is, we know where our background is. We can begin developing our game as needed because we know our drawing area is going to be this giant black rectangle. So as long as we have a folder with index.html and index.js, we can go back to our to-do list and we can go ahead and check off project setup. That is all we need to get started with our project. The next thing we're going to do is create a player and an enemy, and we're going to start off creating these with just pure rectangles. A lot of games are created that way. Developers just insert rectangles into the game, and they code the functionality between those rectangles before inserting sprites. We're going to do the same thing because it's pretty complicated to add some sprites using just vanilla JavaScript and Canvas. It's more important to learn the functionality and the basics behind a fighting game before we go ahead and get to the sprite portion. So in order to create a player and an enemy, we want to make sure that we're within index.js. And although we could create a rectangular player just using fillRect, we don't want to do it that way. We want to use object-oriented programming because we need these rectangles to interact with each other and have their own individual properties that act independent from one another. So in order to create an object, we're going to go ahead and create a class. This acts as the blueprint for the object before we actually create it. So this class is going to be called Sprite because later on when we begin using images and replacing our rectangles with actually moving things, well, moving images in games are basically called sprites. So we're going to call it Sprite in advance, but within this we're just going to start with the rectangles. So whenever you create a class, you need some sort of constructor method, which is basically just a function within the class. And constructor is fired for every time we create a new object from the Sprite class. And so whenever this is fired, we want to define the properties associated with a sprite. So whenever you're doing game development, one of the main properties that you want to put on pretty much any object is going to be position. And whenever you create a property within a class and a constructor, you need to make sure that it's prefaced by this dot. So each time we create a new instance of Sprite, it's going to have a property of this.position. It's going to have some sort of position associated with it, in which we can place it on the screen. But we know our sprites might have positions independent from one another, and if that's the case, we want to go into our constructor function, and we want to pass through an argument. So we want to pass through an argument called position, and each time we instantiate a sprite, well, this position is going to be assigned to the position of the individual sprite we are creating. So now that we have a class of sprite with a constructor, we can go ahead and begin creating our player and enemy. Let's start with our player. We're just going to create a const called player and set this equal to a new sprite. This is how we create a new object from this class right here. So now that we're creating a new sprite, we can look inside of our constructor and see what argument this takes. So it takes a position argument, and this is just the position we want associated with our player. Now, position can be any data type. It could be a number, it could be an object, it could be a string, but in our case, we want to go ahead and make this an object. So I'll go ahead and put an object in here and say that the x for our object should be equal to 0 to start, and the y for our object is also going to be equal to 0. This just means within our game, we're going to place our sprite at the top left-hand corner of the screen to start, and if we save this, and then console log out player, save that, head back to our browser, open up our inspector, and then hit the console tab, and then finally refresh, you're going to see our sprite object is logged out. We successfully created one instance of our sprite class. That is perfect. That is exactly what we want. But now we need some sort of way to define what a player actually looks like. So we also want to do that within our sprite class. Inside of here, I'm going to go ahead and create a draw method. And this is arbitrarily named. We could call this whatever we want, but it makes sense to call it draw because we know when we call this, we're going to draw out our sprite. So whenever we call draw, what should our sprite look like? Well, our sprite should just be some sort of rectangle. As a result, we want to go ahead and call c.fillRect to create a new rectangle. So what we can go ahead and do is we can say, well, I want this sprite to be drawn at whatever position is passed through our constructor right here. So basically what we're doing is we're creating a new sprite, we're grabbing this x and y, we're going on up to our argument right here where position is being passed through, we're passing position through into this right here, and then finally position is going to be stored in this .position, which is the individual property we're creating for our player const right here. But now that we have this object right here being stored in this .position, we can go ahead and reference this .position within other methods within our class. So now that we have this .position, we can use it within c.fillRect to say that our x value should be this .position.x. So now this right here is just referencing this x that we passed through. Our second argument is going to be this .position.y. That's going to reference this y value right here. And then finally, we need some sort of width and height associated with our player. To start, we can go ahead and just put these in as static values. I'll go ahead and say our player is going to be 50 pixels wide and about, let's say, 150 pixels tall. So now we need some sort of color associated with this draw method in order to make sure that it differentiates itself from the black background of our canvas. As a result, we can put in c.fillStyle and set this equal to a string of simply red. And if we assign fillStyle to red right here, right before we call c.fillRect, it's just going to make sure that we're filling in a rectangle with a red color. So if we save this, nothing's going to happen if we go back to our browser, but what we can do is we can select our player const, and then on top of this, call this draw method that we just created. So now, with player.draw below, if we save, go back to our browser, and refresh, you'll see this is what our player looks like. Great, that is exactly what we want to start. So we have our player there. Let's go ahead and create an enemy. We'll put our enemy somewhere over here on the right side of the screen. Kind of makes sense for fighting games, put an enemy over there instead of right next to us. So in order to create an enemy, we can simply just duplicate the code that we created for our player. So we're going to create a const called enemy and set this equal to a new sprite. So what properties does a new sprite take? Well, we know it takes a position. The position is stored within a position property. And we're just saying that we're using an x and a y property within this object we're passing through. So we'll go ahead and say that our x is going to be equal to something like 400, just an arbitrary number off to the right. And then our y value can either be 0, or we can add some numbers onto this to make sure that our enemy is pushed down. We'll go ahead and say our y value is going to be equal to 100. So now we have an enemy created. In order to draw this enemy out, we just need to call enemy.draw, save this, go back to our game over here, refresh, and there's our enemy. Not exactly where we wanted it, since it's not all the way on the far right side of the screen, but this is close enough just to get started. This is all we need. So now we know our player and our enemy are going to be moving objects. And whenever you have moving objects within Canvas, it's pretty standard to add a velocity property onto your sprite class. Velocity is just going to determine in which direction should these be moving when they're inside of an animation loop. So let's go ahead and add some velocity and gravity to make sure that our player and our enemy right here fall to the bottom of the screen and they stop once they hit the bottom of it. So in order to get these moving, we need to create some sort of animation loop. To create an animation loop, we can go to the bottom of our file and create a function called animate. Totally arbitrarily named, by the way. You can call this whatever you want. Animate just makes sense because that's what we're about to do. Now we can call window.requestAnimationFrame, which just says what function do I want to loop over and over and over again. I need to select one. Well, we really only have one function created, and that is going to be animate. So we can go ahead and take this name right here and paste it within requestAnimationFrame. So now, right beneath our function, if I go ahead and call animate, with animate and then some opening and closing parentheses, what's going to happen is we're going to call requestAnimationFrame, and then it's going to say we want to call what? Well, animate. So we're going to go ahead and go right back to calling this function. So if we call this function again, what happens? Well, we call requestAnimationFrame. We call animate. We're basically just creating an infinite loop that we want to go on and on forever until we tell it to stop, so you can begin animating our objects frame by frame. So if we really want to test that animate is working, we can just put a console log inside of it. And I'm just going to put any string inside of here. It doesn't really matter what. And I can go ahead and save this and make sure you're calling animate down below for this to fire. And then off in our browser, if we refresh, and then right click, hit inspect element, and then open up our console tab right here, you'll see we are logging out go over and over and over again. That is how fast our function over here of animate is being called, just really, really quickly so we can begin moving these objects over time as this loops through itself. So now that we know that's working, we want to go ahead and alter our sprite's position so that both our player and our enemy begin to move downwards. They're going to be affected by gravity. So as I mentioned a little bit earlier, we want to go ahead and add a velocity property onto our sprite. To do this, right beneath position, we can add in a new property called this.velocity. And this is going to be equal to a new velocity that we're going to pass through as an argument. So if you need another argument within your constructor, you can go ahead and add a comma at the end of position, and then pass through velocity as the second argument. But one issue I have with this is, eventually as we begin adding more and more properties onto our constructor, well, we need to remember the position of our properties. First we need to pass through position, and then velocity. We can't pass through velocity first, and we can't pass through position second. And as this gets bigger and bigger, it's going to be hard to remember the order of everything. So what I like doing to fix this is, I like wrapping these two arguments within one singular object like so. So now we're only passing through one argument, but within this object argument, we're going to be passing through a position property and or a velocity property. They're not required, and the order does not matter anymore because we're passing them through as properties within an object. Nice little trick to make your code cleaner and easier to manage. So now that we're passing through a position and a velocity this way, we need to refactor our sprite instantiation down below. Before we were just passing through one singular object, so this right here is just equal to our position, but we need to define that. We need to go ahead and wrap this one object in another object. So I'm going to go ahead and do that, wrapping it in opening and closing curly brackets, and then inside of that first opening curly bracket, I want to hit enter, and I'm going to assign the second object equal to a position property. So your first sprite should look like this, and now this is a lot more legible as well. We know that this object right here is equal to our position. So we need to pass through a second property, and that is going to be equal to velocity. So I'm going to add a comma here and say that our velocity is also equal to an object with an x and a y property, because we're going to have two-dimensional velocity to make sure that our object can move left and right, and also up and down. So by default, our player is going to have an x velocity of 0, and a y velocity of 0 as well. This just means that our player is not going to be moving by default. So this is the correct way to instantiate our player now. Let's go ahead and do the same thing for our enemy. We know that our enemy has a different x and y, an x of 400 and a y of 100, but if we want to do this as quickly as possible, we can simply just copy our whole const of player is equal to new sprite, get rid of our const of enemy, and then paste in a duplicate of player. Now all we need to do is change the const of player to a const of enemy, and then set its position back equal to 400 and 100. And now this is instantiated in the correct way. but using a lot cleaner syntax because we added in this object destructuring within our constructor function right here. So if we save this, go back to our game, everything should be the same. We refresh, it is, that is great. It works with all of our new code, but now we can begin using our velocity to move these objects. Now, when I have things moving around, typically I like creating an additional method within my class. This method is going to be called updates. When I want properties updated to begin moving my sprite across the screen, this is where I'm going to call it, is inside of update. So whenever I call update, the first thing I want to do is call draw. We're going to go ahead and call these two lines right here. And to call draw, we can simply write this dot draw. This just means we're referencing this right here. Now, if we want our player and our enemy to fall, we need to go ahead and select their position. So we're going to select them with this dot position dot y. And then we're going to add on to this over time with plus equal. All plus equal means is that we're using this dot position dot y and adding something onto it over time. This is the exact same thing as this dot position dot y plus equal to 10. It's just shorthand syntax to make our code a little cleaner. So we're going to use this shorthand syntax, get rid of this line right here, save, and now what we're saying is over time, our position.y is going to have 10 pixels added onto it for each frame we loop over. But in order for this to take effect, we need to make sure we're calling update within our animation loop down here. So let's go ahead and get rid of player.draw. Because those are only going to be called when our file first loads, we want to make sure that they're called for every frame within our animation loop. So inside of here, we can call player.update instead of draw, because remember, update is still calling this .draw. So we'll call player.update, and then we'll call enemy.update as well. We save this, go back to our game over here and refresh, and you're going to see these are now moving across the screen. Although it's creating a paint-like effect instead of showing the individual objects. So in order to fix this, we need to make sure that we're always clearing our canvas for each frame we're looping over. Otherwise, we're going to get that paint-like effect. So before we update our player and our enemy, right before that, we're going to call our canvas context with C, and then we're going to call clear rect on top of that. Make sure that second R is uppercase. So this is just going to be the same thing as fill rect, but clear rect just means we're not actually drawing anything when we call this method. So how large of a rectangle do we want to clear? Well, we want to start at 0, 0, the top left-hand corner of our canvas, and this should take up a width of our canvas width and a height of our canvas height. So we save that and refresh, and those are indeed falling, but we lost our black background because we're calling clear rect instead of fill rect. Well, I guess clear rect just makes sure nothing is shown in the background at all. So let's go ahead and change this to fill rect. My apologies. Let's just call c.fillrect to make sure we get that differentiation of our canvas and the background. And now what happened? Well, our background is red because the last thing we set for fill style was red right here within draw. So right before we call c.fillrect, we want to set c.fill style equal to black. So that means when we call c.fillrect right here, it's going to be a black rectangle. But then when we call player and enemy.update, they're going to have a fill style of red to make sure that those differentiate themselves from the black background. So I save, go back over here, refresh, things are looking a lot better, although our player and our enemy are going off the screen now. So to get these two to stop at the bottom right here, we're going to want to focus in on our update function. The first thing we want to do is change its static value of 10 equal to the velocity we're actually passing through for both our player and our enemy sprite, because if we want our sprites to stop moving, we're going to have to set our velocity equal to 0 at some point. So what we're going to do here is, instead of adding on 10, we're going to add on this .velocity.y. So for our position on the y-axis, we're adding on our y velocity. If we save this and refresh, now these stay in place because over here, our y velocity for both our player and our enemy is equal to 0. But if we go ahead and change our player velocity equal to 10 on the y-axis and refresh, now our player is moving down. So you can kind of see the benefit of using object-oriented programming is it allows you to go ahead and change individual object properties independent from one another. Right now, only our player is moving down because we said for its y velocity, that should be equal to 10, while our enemy's velocity should be equal to 0. So that's a start, but now what we want to say within update is we want to write an if statement that says if this .position.y. That is going to go ahead and give us the top of one of our sprites. So this right here. So if this .position.y plus this .height. Now we don't have a height property yet on our sprite. Let's go ahead and add one. To add a height property, right below velocity, we'll just add on this .height. We can go ahead and set this equal to the static value we're currently using down here of 150. And now we can swap out this location with this dot height within our draw method. But now we can also go ahead and reference this within our update method as well. So if this position.y plus this dot height, what is that equal to? Well, that's going to be equal to the bottom of a rectangle right here. So if the bottom of a rectangle plus our sprite's velocity is greater than or equal to the bottom of our canvas right here, then we're going to go ahead and set the velocity of our rectangle right here equal to 0, and that's going to prevent it from falling down past our canvas. So with that in mind, over in our code, we have the bottom of our rectangle. We also want to add on this dot velocity on the y-axis. We want to say if this is greater than or equal to the bottom of our canvas, which we can get with canvas.height, because on canvas, y-coordinates at the top start at 0, and the further we go down, the greater they get. So down here will be 576 pixels, which is equal to our canvas height. Then what do we want to do? Well, we want to go ahead and select this dot velocity.y and set that equal to 0. We want to stop our player from moving downwards altogether. So we go ahead and save this and refresh, and that falls down, and then it stops right before it hits the bottom. So you'll see there's a little gap right here. We're going to go ahead and take care of that using gravity. So what is gravity? Well, it's simply just acceleration onto our y velocity. So that just means over time, as long as our object is up in the air, we're going to keep adding a value onto this dot velocity until it hits the ground. And if we keep increasing our velocity over time, the faster it's going to get, the longer it falls. It's just like real life gravity. So to create gravity, right above our class, we can create a global const called gravity and set this equal to something like, let's just say 0.2 to start. That should make it fall relatively on the slower side. So we'll go ahead and save that. And we want to keep our code right here the same, but right before we affect our position on the y-axis, we can go ahead and say that this dot velocity.y is going to have some sort of value added onto it over time, and that is going to be gravity. It's going to be a value of 0.2. So now we don't need to say our velocity on the y-axis is equal to 10 because this is going to be affected by gravity over time. It's going to add that downwards acceleration to our objects. So we save this and refresh. Let's watch what happens. We refresh, and that gravity is looking pretty darn good. You'll see that it had that acceleration as it was pulled downwards, but we do have an issue. Well, our player and our enemy are going off the screen. That is not a very good fighting game. So to fix this, what we can do is we can grab this code we just put in and say we don't want to call this for every frame. Otherwise, we're just going to keep forcing our player downwards. But rather, we want to call this if this is not equal to true. So if we go ahead and add an else statement right here and paste in this dot velocity.y plus equal gravity for that else statement, now we're only going to be adding gravity onto our y velocity if our player and the enemy are actually above this value right here, which is our canvas height. So let's go ahead and save that and refresh, and you'll see both of these are pretty much in the perfect position. There's no gap beneath either of them because gravity took into effect to make sure that these are pulled to the very bottom of the screen over time and that they're not pulled down any further as long as this is equal to true. So with this, we are looking to be in great shape. And that leads us back to our to-do list. We can go ahead and check off create a player and an enemy. So now we're going to go ahead and move our characters, both our player and our enemy, using event listeners. We're going to go ahead and make this a 2-player game to start because coding AI is pretty dang complicated. So we're going to go ahead and just focus on the essentials, at least to start. Maybe in some premium tutorials later, we'll go ahead and add in AI. Let's go ahead and get our characters moving, both our player and our enemy, using event listeners. So within our code, we want to go ahead and add an event listener. This is just a snippet of code that listens for some sort of specific event. So to add in an event listener, we can call our window object, and then on top of this call, add event listener, like so. So this is going to take one argument, just a simple string, which declares what kind of event do we want to listen for. So there are things like click, there are things like touch. We want to go ahead and listen for an event of key down. This is an event that occurs whenever we press any key on our keyboard. So here we're going to add in an arrow function as our second argument. And this is what's going to be fired for any time we press down on a key. And within this arrow function, we can pass through an event object, like so, and then console log out within our arrow function this event object so we can see what's inside of this. So if we go ahead and save this, right click, hit inspect element, and then open up our console, and then make sure that we clicked on our canvas, and then we press down on a key. I'm going to go ahead and press K. You're going to see that we just logged out that event object. So this is a keyboard event. And if I open this up, we have a bunch of different data properties associated with that event. So here you can see we pressed a key of K, Here we press the key of K. A lot of the stuff, I don't even know why it's here, but the thing we want to focus in on is what key are we currently pressing. So this property right here of key is what we want to bring into our code. So right here we can reference event.key, save that, go back over to our game, refresh, click on our canvas, and then start pressing keys. You're going to see I'm logging out each key that I press down on our keyboard. That's exactly what we want, because we want to determine which keys should move our player in which direction. So if I go ahead and move this off to the right side by clicking these right here, clicking dock to right, now we can keep our console open while seeing both our player and our enemy as well. So back within our code, within this key down event listener, I want to go ahead and add in a switch case statement. And within this switch, I'll go ahead and reference event.key and say for a case of what? Well, a case of D, then I want to go ahead and call the following code and then call break. So what I'm saying right here is I want to go ahead and grab the key we're currently pressing with event.key, and if that key is equal to D on the keyboard, then what do I want to call? Well, I'm going to want to call some code that moves our player. So whenever I press D, I want to select our player, and then I can set our player's velocity on the x-axis equal to about 1. This means we're going to be moving 1 pixel for every frame we loop over within our animate loop. So if I save this and refresh and then hit D, well, we're not actually moving even though I'm clicking the key, because we need to define how our player should be moving on the x-axis. If we look within our update function right here, we only define how our player is moving on the y-axis. We need to do the same thing for the x. So right above this .position.y, I'm going to reference this .position.x, and over time we're going to add on this .velocity.x. So with this simple line of code, if I save that and refresh, now when I go ahead and hit D on the keyboard, we have our player moving on over to the right simply because I hit D on the keyboard. Now this is just going to keep going because I didn't declare what should happen when I lift up on a key. So back within our code, we're going to want to add in a new event listener right beneath this one, but to add in that event listener, I want to copy this one we just created. So go ahead and copy that, paste it down below, and I want to listen for an event of key up rather than key down. So whenever I key up, well, I want our player velocity on the x-axis equal to 0. So I save that, refresh, and then hold down D. You're going to see that's firing, we're moving over to the right, but as soon as I lift up, you're going to see we stop because we set our player's velocity on the x-axis equal to 0. So this is a great way to get our player and our enemy moving to start. Let's go ahead and make our player be able to move to the left as well. So to get our player to move to the left, all we need to do is copy this case statement, paste it down below, and then say, when should our player move to the left? Well, when we have a case of A, we know when we press down the A key, our player should be moving leftwards. But in order to move our player leftwards, we need to make sure that our player velocity on the x-axis is a negative value rather than a positive one. So we're going to set our player velocity on the x-axis equal to -1, and then when we key up, we're going to set that back equal to 0 no matter which key we press, but we need to make sure that we add in that additional case for when we lift up on the A key. So when we go ahead and lift up on the A key as well, our player velocity on the x-axis is going to be equal to 0. So I save that, go back over here and refresh. Now when I hold down D, we start moving to the right. I let go, we stop. And then when I start holding down A, we go to the left. When I lift up, we stop. So that's cool, and you might think we're done, but there's something I want to show you. If I go ahead and hold down D, well, everything looks great, right? But now, if I keep holding D down, and I press A to go to the left, looking great. But if I lift up on D, I'm still holding down A, but we're not moving to the left. That is because within our code, even if we're holding one of these down, we're saying whenever we lift up on either D or A, we're setting our player velocity x equal to 0. This occurs after one of these occur, so therefore we're stopping our player from moving just by lifting up on any key. As a result, we don't want to set our velocity within our key down or key up function. We want to go ahead and set it within our animate loop instead to make sure we have the most accurate movement possible within our game. So I already have a pretty good method for doing this. This is by creating a const, and I'm going to do this right above function animate, a const called keys. This is going to be equal to an object that declares all the keys we want to use to control our game. So the first key I want to use is going to be A. I'm going to create a new object assigned to that, and then I want to go ahead and create a pressed property and set it equal to false to start. So this is what our first property is going to look like, and now I also know I want a D property to move our character to the right. So I'm going to monitor for our D key by copying this property right here, adding in a comma, and then pasting in that second object. Say instead of A, I want to reference D. By default, this is going to have pressed equal to false. And now, within animate, I can say if keys.a.pressed is equal to true. Well, I want to go ahead and set our player.velocity on the x-axis equal to 1. And then I can write an else if in here that says if keys.d is equal to pressed. What do I want to do? Well, I want to go ahead and call player.velocity.x is equal to 1 here, actually. So if we go and look at a, well, a means we should go to the left. This should actually be set equal to -1 instead of 1. But let's go ahead and save that. Nothing's going to happen on refresh because we need to set a.pressed or d.pressed equal to true when we actually press down on one of these keys. So to set a.pressed equal to true, we're going to do that within our keydown event listener. And right here, when we press down a, we're no longer going to set our player's x velocity. Rather, we're going to grab keys.a.pressed, and we're going to set this equal to true because we know we just pressed down on our a key. But whenever we lift up on our a key down here, we want to select the same thing. So keys.a.pressed, but here we're going to set it equal to false. Let's go ahead and do the same thing for our d key. I'm just going to copy this line of code right here. Within our case of d, I'm going to get rid of player.velocity.x equal to 1, paste in keys.a.pressed equal to true, but instead of referencing a, this should be our d key, which we assigned right about here. And then when we're listening for key up, we want to go ahead and select keys.d.pressed, and instead of setting our player velocity x equal to 0, we're going to set keys.d.pressed equal to false whenever we key up on our d key. So now for each loop of our animation, we're going to be listening for whether or not one of our keys is pressed down, and it doesn't matter if we key up now, we're still going to be moving either left or right, because our key up event listener is not responsible for our player's actual velocity on the x-axis. So let's go ahead and save this and refresh and see what that looks like. So now if I go ahead and hold down D, we're moving to the right, but watch what happens. If I lift up, we're still moving to the right. That's okay. But if I go ahead and press down A, now we're moving to the left, but we keep on going even though both hands up, I'm not actually pressing down on any of the keys. So right before we actually set our player velocity equal to either -1 or 1, we need to make sure that before this, we set player.velocity.x equal to 0. So the default value for our player's x velocity is going to be equal to 0, but if one of these is equal to true, then we're going to set it equal to 1 and move our player in that direction. It's going to make sure that we stop whenever we lift up on one of our keys. Save and refresh. Now if I go ahead and hold down D, we move to the right, but if I lift up, both hands up, we stop moving. Great. If I go ahead and hold down A, we move to the left. Now watch what happens when I hold down D, and then I press A while I'm holding down D. We start moving to the left, but if I lift up D, we keep on moving. So we fix that issue in which our player stopped if we lifted up on one of the keys. Now you might think we're good to go, but there is one more improvement we want to make here to give us the most accurate movement possible. So if I go ahead and I move our player over to the right, and I stop, and I hold down A, and then I hold down D, well, they're both pressed down, but we're moving to the left even though I just pressed down D. Why is that happening? Well, if we look within our code, specifically this portion right here, let's analyze this. Well, if A is pressed, we're moving to the left. But if A is not pressed, then we're going to go ahead and move to the right if D is pressed, only if D is pressed. The thing is, if I go ahead and press down A first, we're going to be calling this code right here. And then when I press down D, yes, we do want to call this code, but only this first if statement is going to be called because this value right here is still pressed down. To fix this, we want to go ahead and add in some sort of let, some sort of variable that tracks the last key that we press down to make sure that we get the most accurate movement possible, and that when we go ahead and press down on our D key while A is also pressed, the D key overwrites that, and we make sure that our player moves to the right because that was the last key we pressed down. So to do this, right beneath our keys const, I can go ahead and create a let, and this is going to be called last key. I'm not going to assign anything to this to start, but whenever we key down and have a case of D, I want to select our last key and set that equal to D, just a simple D string. And then right here for our case of A, I'll go ahead and select our last key and say the last key we pressed down was A. So now, keys.d.pressed and keys.a.pressed, those can be equal to true at the same time, but last key is only ever going to be equal to one value, and that is going to be the last key that was pressed down. We don't need to do anything within key up, we just want to know what was the last key we pressed down, so nothing within key up. Now that we are monitoring which key we pressed last, we can use this within our if and else if statement. So if keys.a.pressed is equal to true, and our last key is equal to A, then we're going to go ahead and move our player to the left. Else if keys.d.pressed is equal to true, and our last key is equal to D, then we're going to go ahead and move our player to the right. So that should fix our issue with overriding which direction our player should be moving. So I save that, I go back to our game, I refresh, and I begin holding down D, looking great. I hold down A, we're now moving to the left, lift up on D, and then I start holding down D. That overwrites A, even though I'm still holding down A at the moment. So that's how we're going to add pretty much perfect movement to our game using event listeners and our animation loop at the same time. Now let's also add a jump effect to our player. To add a jump effect, well, we want to listen for on key down another case. This is going to be a case of not A, but rather W. This is going to be our player on the left-hand side of the screen. Whenever we press the W key, we're going to jump upwards. So we want to go ahead and select our keys object, specifically a W property, which we haven't created yet, but we will. And then our last key is going to be equal to W. That's the last key we press down when we key down on W. Then within key up, we know we need another case to listen for whether or not this key is currently pressed. When we have a case of W, we know keys.w.pressed is equal to false. So we just need to go ahead and create this property right here. And we can do so within our keys object by setting W equal to an object with pressed equal to false. So to create a jump effect, the first thing we want to do is add in a new case whenever we key down. What case do we want to listen for? Well, simply a case of not A, but W. We're actually going to do this a little differently for moving our player to the left and to the right. We don't have to monitor for whether or not this key is pressed, and we don't have to use a last key. What we want to do is just go ahead and select our player velocity on the y-axis and set this equal to something ridiculous. So let's just say something like -10. If we go ahead and set this equal to -10 whenever we press down on W, we go back to our game, refresh, let our player fall, and then we go ahead and hit W on the keyboard, you're going to see that our player just moves upwards and falls down perfectly. Because we added gravity into our sprite class, right on up here, right here, we know we're always adding on gravity to our y velocity if the bottom of our player is above the bottom of our canvas. So as long as our player is above this, we're going to keep on pulling our player down by altering our player's y velocity. And since our y velocity is always being added onto our player's y position over time, when we set our velocity.y equal to 10, we're just shooting it upwards. We're basically just saying move upwards as quickly as possible using a velocity of 10. And then over time, we're pulling that back down because we know we're calling else. And when we call else, we're adding gravity back onto our velocity until it hits a velocity of 0, which is going to keep our player on the ground. So that's how that works down here, is we're setting our player velocity y equal to -10. When we press W on the keyboard, we move up, and then gravity pulls us back down. That's all we have to do to create that jump effect. So now let's go ahead and move our enemy over here using our arrow keys. So to monitor for our arrow keys, we want to listen for a case, but we might not know what case an actual arrow key is. So if we want to go ahead and monitor that case, we can go ahead and console log out our event object, specifically the key property. If we go ahead and save this, go back to our browser and refresh, and then we only press down on some of our arrow keys, so I'm going to press the right arrow key. You're going to see that gives us a value of arrow right. I know I also want to press down on our left arrow key. It's going to give us arrow left, and if I press up, that'll give us arrow up. So these are the values that we want to listen for within our case statement. So I'm just going to go ahead and duplicate these three, and then we're going to go ahead and paste in 3 new case values. So D should actually be arrow right with the exact same casing that we saw over here in the browser, which that is correct. And whenever we press down on arrow right, well, keys dot arrow right dot pressed should be equal to true. Now for last key, well, we don't want to set last key equal to arrow right because this is going to be our second player essentially. We don't want to overwrite our first player's movement by setting last key equal to something like arrow right. As a result, it makes sense to add in a last key property onto our sprite class because we know this property is going to be independent for both our player and our player2 enemy objects. So instead of referencing last key like this, I'm actually going to go into our class's sprite and say that this dot last key is going to be a property within our sprite class, but it's not going to be equal to anything by default. But now that I have that declared, I can say within arrow right, I want to go ahead and select our enemy, specifically the enemy's last key property, and set that equal to a string of arrow right. And now I can delete this last key right here. So now I just need to make sure I do the same thing for arrow left. So I'll get rid of A and say whenever we press down, arrow left, keys dot arrow left dot press should be equal to true. And not our last key, but our enemy last key should also be equal to arrow left. And then finally, we need to say what happens when we press on the up arrow key. So when we have a case of arrow up, we want to go ahead and select our enemy, .velocity.y, and set that equal to -10 instead. So that takes care of our key down event listeners for our enemy, and we need to make sure that we add in our key up event listeners as well. So I'll go ahead and duplicate the switch case statement right here for key up for our player. We can go ahead and comment this out to say this is our enemy keys right here. We're going to paste in a duplicate of that and say whenever a case of arrow right is keyed up on, then we want to go ahead and declare keys.arrowRight.pressed is equal to false. Whenever a case of arrow left is lifted up on, then we want to go ahead and say keys.arrowLeft.pressed is equal to false as well. So that'll take care of key up. Now we need to go ahead and add this into our animation loop. So this if statement is going to be player movement. We can go ahead and duplicate all this code right here, paste it below, and say that this is going to be our enemy movement. So to move our enemy, if keys, not A is pressed, but rather arrow left is pressed, and our enemy last key is equal to arrow left, then we want to go ahead and select our enemy's velocity on the x-axis and push it over to the left. Then within this else if, we want to select our keys, .arrow right, if that is pressed, and our enemy last key is equal to arrow right, then we're going to set our enemy velocity.x equal to 1. So what do we need to do now? Well, within our keys up here, we need to make sure that we're adding in arrow right. That's going to be equal to an object with a pressed property equal to false. We also need to add in arrow left. That'll also be equal to an object with a pressed property equal to false. And we should be good to go with that. So let's go ahead and save, refresh over here, and then we're going to test out our arrow keys. So if I go ahead and hold down on the left arrow key, you'll see our enemy over here is moving to the left. If I hold down on right, well, now we're moving over to the right, and you're going to have to excuse some of this movement right now because I have this console open, just kind of messing things up a bit when I press down on those. But we do have the same issue in which our enemy continues moving, even though both hands up, I'm not pressing down on any of the keys. So back within our game, right here, we're setting our player velocity x equal to 0. We also want to make sure we're setting our enemy velocity x equal to 0 as well to make sure that we stop for every frame we're not holding down on a key. I save that, I go back, hold down on the right arrow key, lift up, we stop. Hold down on the left arrow key, lift up, we stop. But if I go ahead and hold down D for our player, that moves as well. And now watch what happens when I press on the right arrow key. We can move both of these at the same time independent from one another. So it's a pretty classic game style where you used to have to sit next to your friend and use different keys on the keyboard to actually get things moving around. So to finish up this movement with event listeners, I just want to make sure that our enemy and our player move a bit quicker throughout our scene. And I also just want to go ahead and refactor some of our player code real quick. Let's go ahead and do that first. Let's refactor that player code. What code do I want to refactor? Well, it's going to be within our event listener right here. We don't want to listen for last key anymore because we don't need that independent variable. We created a property for our sprites, so instead we can reference our player last key, set that equal to D right here. And any place where last key is by itself, we're going to make sure that we prefix that with player. So these two locations right here are going to be player.lastKey. And then when we listen for last key within our animation loop, we're going to say and player last key for A, and player last key for D. And then finally we can get rid of this let right here because we know we created that property within our sprite class. So if I save that, refresh, hit down D, we move to the right, lift up, good to go, hold down A, lift up, good to go. So just a small refactor to get rid of that let that we no longer needed. Now let's get everything moving around a bit quicker. If we want everything to move around quicker, we just need to increase these values right here. So I think a good speed for a fighting game, instead of 1s, is going to be 5. This just means we move at 5 pixels per frame instead of just 1. So each location in which 1 is currently at within our animation loop, I'm going to change that equal to 5. Save and refresh over in our browser. Now if I hit down D, we move a lot quicker for both our enemy and our player. If I jump, well, that's pretty slow still. To make sure that our enemy and our player fall down quicker, we just need to change the value of gravity. So up above, when gravity is equal to 0.2, we fall down pretty slow, but if we increase this to something like 0.7, save and refresh, and then start jumping, you're going to see we fall down pretty quick, although we don't jump as high. So how do we go ahead and fall down at this rate, but jump higher? Well, we do want to go ahead and increase gravity. We'll keep it at 0.7 for now, But within our event listener, specifically when we key down on either W or arrow up, we just want to set this equal to a higher value. So I'll go ahead and set it equal to 30 for both W and arrow up. Save and refresh. And now when I go ahead and press W, you're going to see, well, maybe a little too high right there. We're going into outer space. Let's go ahead and decrease it to something like 20. Just say that both of these should be equal to 20. Save and refresh. And then jump. I think that's pretty good for the jump in our game. So now we have some really responsive movement between our player and our enemy, and using a good method to make sure that our keys overwrite which one is supposed to control the direction in which our character or enemy is moving. So with that, we're going to be able to check off move characters with event listeners. So now we're going to go ahead and create attacks for both our player and our enemy. How's this going to work? Well, over here, when we go ahead and move closer to our enemy on the right hand side, eventually we're going to go ahead and press something like spacebar. What this is going to do is it's going to activate a rectangle that's drawn on top of our player. This rectangle is going to represent our attack, whether it be a sword swing or a punch. It's going to represent either one of those. So what we want to do is monitor for collision between this rectangle and our enemy. Is this rectangle currently touching our enemy? No, it's not. So we're going to say the attack missed. We're not going to do anything. But if we go ahead and move our player a little closer, now our rectangle, when we go ahead and press spacebar, should indeed be touching our enemy. Therefore, our enemy has been hit. We're going to go ahead and subtract health from our enemy's health bar. So to get this effect, we need to go ahead and create this rectangle on top of both our player and our enemy for when our enemy wants to use an attack. So to create that rectangle, we're going to go back to our code over here, and we're going to focus in on our class of Sprite. So that rectangle, I'm going to add it in as a property of this dot attack box, like so. Now what is an attack box? Well, it's going to be equal to an object, and it's basically just a rectangle. So what properties does a rectangle have? Well, they're going to have a position property, and they're also going to have a width and a height. So we'll add in properties for width, height, and position right here. Now what should position be equal to? Well, I want our attack box's position to always follow our player around. Therefore, I'm going to make it based on the position of our actual player. It's going to be starting at the top left-hand corner right here. To make sure that it always follows our player around, well, we can assign position right here equal to this dot position. And by default, whenever position changes right here, our attack box position is also going to change as well. That's perfect. That's exactly what we want. Now for our width, I'm just going to go ahead and give this a value of 100 to start. And for height, I'm going to make sure that height is equal to 50. So now, if we want our attack box drawn out, we're going to have to go inside of our draw function. Right beneath this code right here, I'm going to create a comment that says, this is where attack box is drawn. And I can go ahead and draw this with c.fillRect. So the first argument is going to be the position of the attack box. So this dot attack box dot position dot x. The second argument is going to be this dot attack box dot position dot y. So the y position of our attack box. And then we need the attack box's width and height, which we can get with this dot attack box dot width. And then our fourth argument is going to be the height of our attack box, and we can get that with this dot attack box dot height. So if we save this and then refresh our game over here, you're going to see now our attack box is drawn on top of our player and our enemy. So it's kind of hard to tell right now what is our player, what is our attack box. So right before we're drawing out the c.fillRect, we can add in c.fillStyle, set that equal to a different color, such as green, save that, refresh. Now we know what our attack box is and what our player is. So now we need to detect for a collision between this attack box right here and our enemy. Is this attack box touching our enemy? Well, now it is. We need to detect for that and tell our game what should happen as a result. Now to detect for a collision, it's going to be a little hard to tell what is our player and what is our enemy as we go about doing this. So I want to make sure that our enemy is a different color from our player, just so we can see where things are relative to each other as we go about coding this. So we want to change the color of just our enemy. What we can do is we can set this fill style right here equal to an argument we pass through our constructor. So instead of referencing red, I want to go ahead and say that this is going to be equal to this dot color, which means we need to create a property for this dot color right up here within our constructor. So this dot color is going to be equal to color, which now we're going to pass through as an argument right here. So we're going to pass through that argument of color. By default, I'm going to set this equal to red. So we save that and refresh. It's still going to function exactly the same, but now that we have this as an argument, what we can do is down below where we're actually creating our player and our enemy, when we go ahead and create an enemy, we can say that we want the enemy color to be equal to a string of blue. If we save this, go back over here, Now we can easily differentiate between our player and our enemy because our player is red, our enemy is blue. This is going to be really good for when we go ahead and detect for collision. Let's go ahead and do that now. To detect for collision, we need to go inside of our animation loop. Right beneath where we're setting our player and our enemy movement, we're going to go ahead and detect for collision right here. So to detect for collision, we need to go ahead and write an if statement. And what does this if statement say? Well, we need to go ahead and say, is the right side of our attack box right here greater than or equal to the left side of our enemy? If this is past this point right here, we know the two are colliding in that case. We're going to start off with that. So how do we get the right side of our attack box? We're going to go ahead and get that with our player.attackbox.position.x. That's actually going to give us the left side of our attack box. So this right here. But we need the right side, and to get that, we can get it with player.attackbox.width. That is going to give us the right-hand side of our player's attack box. Perfect. But now we need to say, is this greater than or equal to the left side of our enemy? So we can do that with greater than or equal to the left side of our enemy, which we'll get with enemy.position.x. Now if this is true, we can go ahead and console log out any text, such as just go. It doesn't really matter what we put here. But if we save this, go back to our game, right-click, hit inspect, go to console. Now, we're not actually console logging out go until the right side of our attack box is greater than or equal to the left side of our enemy right here. As soon as I go off of that, you'll see that stops logging out. That is perfect. That's what we want to begin detecting for collision. But now watch what happens if our attack box goes off of our enemy. If I keep moving, even though our attack box is not touching the enemy, well, we're still console logging out go. So now we need to add in an additional conditional. What is that conditional going to be? Well, we need to detect for whether or not the left side of our attack box right here is less than or equal to the right side of our enemy. We're basically just going to do the conditional in reverse that we just wrote. So to get the left side of our attack box, we want to go ahead and add in an and statement that says, is our player.attackbox.position.x, that is the left side of the attack box, is this less than or equal to what? Well, the right side of our enemy. We can get the right side of our enemy with enemy.position.x. That'll actually give us the left side, but to get the right side, we add on the enemy's width, and that's going to make sure we get the right side of the enemy. But if we're referencing a property of width on the enemy, and we look within our class up above, right up here, you'll notice we never actually assigned a width property to our sprite class. We need to make sure we do that in order for this collision detection to work properly. So right above height, I'm going to add in a property called this.width, and I'm going to assign that to the 50 we're currently using to draw out our player. So width is going to be equal to 50. Here we can replace 50 with this.width. And if we save that, go back to our game, now our collision detection should work as expected on the x-axis. So we're no longer console logging out go, which is great. Now when our attack box touches our enemy, we're logging that out. But if I go past our enemy over here, we're no longer logging out go until the left side of our attack box is past the right side of our enemy. So eventually, we go to that point, and now we are touching. We know that our enemy should be hit in this case. Now we're also going to want to account for the y-axis. You'll see if I begin jumping, and I move into our enemy's area, we're still logging out go, even though our attack box isn't necessarily touching the enemy. So we need to make sure that we monitor for collision on the y-axis. We want to say, is the bottom of our attack box right here greater than or equal to the top of our player? In this case, it definitely is. So we would want to say that these two are colliding, but as soon as we jump up, that's not the case. We want to set that equal to false. So let's go ahead and write this conditional. We want to get the bottom side of our player. Let's go back to our animation loop. This is where we're detecting for collision. We want to add in an and statement that says, get our player.attackbox.position.y. We want the bottom of our attack box though. This right here is currently the top of it. To get the bottom, we'll add on our player.attackbox.height. We want to say if this is greater than or equal to the top side of our enemy, which we can get with enemy.position.y, then we know the two are colliding, but we do need to add in one more conditional to make sure that this is as accurate as possible. We want to get the top side of our player's attack box, which we can get with player.attackbox.position.y, if this is less than or equal to the bottom side of our enemy, which we can get with enemy.position.y, plus enemy.height, then we know the two are indeed colliding on the y-axis for sure. So let's go ahead and save this. Refresh over here. And now when we go ahead and jump up and down, when we're overlapping our enemy with our attack box, that's going to go away. That's exactly what we want. We know our collision detection is correct for when our attack box is overlapping on top of our enemy. So right now, we're basically walking around with our sword out at all times. That's not really a fun fighting game. We can't just walk into an enemy and say, hey, you got hit. We need something that actually activates our sword to say that this is the exact moment in which our enemy can be hit. So within this conditional, we're actually going to add in one more AND statement that says if our attack box is colliding with our enemy and our player is attacking, then we know our enemy did indeed get hit. So basically we need to add a property onto our player that says whether or not they are currently attacking. Let's go ahead and add that property on. We'll go on up to our Sprite class, and then here we'll add in a property called this.isAttacking. We're not going to assign it to anything by default. It's going to be equal to false. But in order to activate this to true, right beneath update, we can add in an attack method. And whenever we call attack on one of these objects, we're going to go ahead and set this.isAttacking equal to true. Now we should only be attacking for a certain period of time. We go ahead and set this equal to true without setting it back equal to false. Well, it's going to say we're always attacking at all times. We only want to activate this for a certain period of time. So we're going to call a function called setTimeOut. It's going to take an arrow function as the first argument and a time as the second argument. For the time, we're going to put in 100, which should be equal to around 100 milliseconds, I do believe that is. But basically, within the setTimeOut arrow function, we can set this.isAttacking equal to false. So when we call attack, this.isAttacking is going to be equal to true. Then after 100 milliseconds, this.isAttacking is going to be equal to false. So just make sure that we set this back equal to its original value at some point in time. But we do need a way to activate this attack method. We're actually going to do that within our event listener down below, where we're listening for key down. So if our event key for our player, which are these cases right here, has a case of space, we're just going to include an empty space right here for our case, which just means we press down on the space bar. What do we want to do when we go ahead and press down on space? Well, we want to go ahead and say that our player is going to attack whenever we press down on the space bar. So if I go ahead and save this, and go back to our game, and I walk into our enemy, you're going to see that we're no longer console-logging out to go, but as soon as I press space, it's going to set isAttacking equal to true, which means we're going to activate our collision detection code, which should console log out go. So let's go ahead and press space, and you'll see for that brief period of time that conditional was true. Our attack box was overlapping with the enemy, so we console logged out go for that period. If I go ahead and move off our enemy, and I press space, we're not logging out because our attack box is not touching the enemy. If I go back over here, press space, we're logging it out once more because we know we're currently attacking at that point in time. So you'll see go is being logged out a couple of times. That means our enemy has been hit, but we know our enemy didn't get hit 4 or 2 times in a row. They only got hit once. So whenever we go ahead and detect for collision and we console log out go, we immediately want to set player.isAttacking back equal to false. And just with this, if we go back over here and refresh and move inside of our enemy and then hit space, you're going to see that now we're only logging out go once. That's exactly what we want, to subtract the accurate amount of health from our enemy when we hit them. Now it doesn't really make sense to show our attack box at all times. It's kind of confusing actually. So back up in our Sprite class, we can make sure that we're only showing it when we're actually attacking. So where we're actually drawing out our attack box, we can write above it if this.isAttacking. If this is equal to true, then we want to go ahead and call the draw code inside of it. Otherwise, we're never going to draw it. So if I save and refresh and I hit space, you're going to see that our attack box only shows for that brief period of time, and we're only going to log out that this got attacked if we're currently overlapping with our enemy. So that is exactly what we want to begin creating attacks within our game. So that's how we're going to add attacks for our player. Let's go ahead and add attacks for player 2, or our enemy as we've been calling it, to make sure that this blue guy over here can fight back towards the red one. So to get our enemy's attack box positioned in the correct spot, I'm actually going to comment out this if statement we just wrote, just so we can see the attack box at all times. See it refresh, and that's looking good, but we do want this attack facing towards the left, so we need to move this attack box over some. To change the position, we need to make sure that our attack box's position is not completely dependent on the position of our actual player or our enemy entity. So to do this, we're going to go ahead and change position right here, equal to an object with an X and a Y property, and then X by default is going to be equal to fighter's position, which we can get with this.position.x and this.position.y. Now when I save this, and I refresh, you're going to notice that our attack boxes are staying up in the sky. That is because with this change, we no longer have a shallow copy of our parent position. When we don't have a shallow copy, what that means is position.x is no longer going to be directly linked to this .position. We need to go ahead and make sure that our attack box's position updates manually based off position of the parent. So to do this, we just need to head inside of update, and right beneath this .draw, we'll say this .attackbox .position on the x-axis is going to be equal to this .position .x, and then we'll do the same thing for attack box position on the y-axis. It's going to be equal to this .position.y. So I save that and refresh. Now those follow accordingly, which is great, but we do need to offset our enemy's attack box. So to add in that offset, we're going to want to focus in on where we're setting our attack box's position on the x-axis. So we're setting it equal to our current parent position, but we also want to subtract from it some sort of offset. If we go ahead and subtract 50 from here, save and refresh, you'll see that moved over a little bit for our enemy's attack box. But it also moved over our player's attack box as well. We don't want that. We want this value right here to be dynamic based on what we're passing through our constructor. So instead, we're going to go ahead and subtract from this .attackbox.offset.x. So we need to create this offset property, and we're going to create it within our attack box right here. So we'll add an offset, and this offset is going to have an x and then also a y. What is x going to be equal to? Well, whatever offset we pass through within our constructor. Let's go ahead and pass through just one offset object. We'll add it within our constructor, an offset property, and then we can go ahead and just set offset equal to that property we're passing through. So offset is going to be equal to the offset we're currently passing through. And if we want to use shorthand syntax, we can actually get rid of this colon and offset, because since these two have the exact same name, we can simply get rid of the colon offset. This right here is the exact same thing as this right here. It's just shorthand syntax to make our code a little cleaner. But now that we're passing through an offset argument, we need to make sure we're doing that whenever we're creating a sprite. So right here, we're going to add in an offset argument. We're just going to have an x and also a y. Our x for our player isn't going to be anything. It's going to be 0. And same thing for our y. We're just going to keep it where it is at the moment. But if we want to pass through an offset argument for our enemy right here, we can say that our offset for our attack box on the x-axis is going to be -50. So we save that. Now this -50 should take effect by being set to offset right here, which means when we go inside of update, we're going to call attackbox.offset on the x-axis. This right here is going to be equal to -50. So we don't want to subtract the -50, but rather add it on. That's going to give us the correct effect that we want. And if we save that and refresh, now our attack box for our player is in the correct spot, and our attack box for our enemies is in the correct spot as well. Just need a little bit of refactoring in where this rectangle is drawn. So now we want to monitor for collision between our enemy's attack box and our actual player over here. So to do this, we're going to focus in on where we're currently detecting for collision between our player's attack box and our enemy. We simply just want to go ahead and duplicate this code, but refactor it for our enemy's attack box and our actual player. But this code is kind of hard to read because we have so many AND statements inside of here. It would make a lot more sense to refactor this into its own function that detects for collision. As a result, I'm going to go ahead and copy these first 4 conditionals which are actually detecting for that collision. And right above animate, I'm going to create a new function called rectangular collision. This is going to detect for a collision between 2 rectangles. And inside of here, I'm going to return some parentheses and paste in those 4 conditions I just copied. So now if these 4 conditions are true, we're going to return true. If they're false, we're going to return false. But in order for this to work, we need to make sure that we have a player.attackbox.reference and that we have an enemy.positioner.reference as well. So whenever we call rectangular collision, we also want to pass through an argument. It's just going to be a singular object, which takes a rectangle, 1 property, and then a rectangle, 2 property as well. So what is the first rectangle we want to detect for a collision with? It's going to be our player rectangle. So everywhere where we have player, I'm going to go ahead and replace player with rectangle 1. And then every place we have enemy, it's going to be in these couple of locations right here. I'm going to replace that with rectangle 2. So now we have a reusable rectangular collision function in which we can use to detect for a collision between our attack boxes and our fighters, but it's also going to be usable for when we want to use it with our enemy. So down below, when we're detecting for a collision, we can get rid of these first 4 conditions, and then we can call rectangular collision. What does this take? It takes 1 argument, which is going to be an object, and inside of this we have 2 properties. It's going to be rectangle 1. What is the first rectangle equal to? What's going to be equal to our player. And then the second rectangle is going to be equal to our enemy. So if our player's attack box and our enemy are colliding, and our player is attacking, we should console log out go. Let's save this and refresh to make sure this is working. Have our console open, move closer, and then I hit space. That indeed is still working, but we want to make sure that we get this going for our enemy as well. So what we can do is we can copy this if statement, paste it below, and now our rectangle 1 is going to be our enemy. We want to detect for our enemy's attack box and what? Well, our actual player. If this is the case, and our enemy is attacking, then we know enemy.isAttacking is equal to false eventually because we know we hit them, but we should console log out enemy attack successful. So the last thing we need to do is determine what button we want to press down in order to set enemy.isAttacking equal to true. We're going to do that within our keydown event listener and say we're going to add in a new case. Let's just go ahead and say our down arrow is when our enemy attacks. So for arrow down, I want to go ahead and select our enemy and say is attacking is equal to true. So now whenever we press down on the down arrow key, our enemy is going to be attacking. So I save that, and then I refresh, move this off to the side just a little bit, and I move closer towards our player. As long as our attack box right here for our enemy is inside of our player, and I hit down, you're going to see our enemy attack was indeed successful. We're just getting a bunch of console logs over here at the moment because we're console logging out our event keys. We no longer need these console logs. Let's just go ahead and get rid of them and both key down and also key up and refresh and do that one more time. Move over towards our player, hit down to attack. Enemy attack was successful, and now since our player is also overlapping their attack box on our enemy, if I hit space, we're console logging that out as well. We know that these two methods are now working for attack. So to finish this off, we can go back up to our class, and we can uncomment this code where we actually draw out the rectangle for when we're attacking. Save that and refresh. Now when I go closer towards our player, you can see that our enemy attack box is showing. Enemy attack was successful. When I hit space for our player, now we're console logging out to go. That means our player attack was successful. So with that, we can go ahead and check off attacks. Next, we're going to add in a health bar interface. So what we're going to do is we're going to create some HTML elements that look like this. Essentially, this bar on the left is going to indicate our player's health, and this bar on the right is going to indicate our enemy's health. We're going to have a timer in the middle, but it's most important that we just lay this out correctly so that when we start hitting something like our enemy while their health decreases over time. So how do we recreate this effect that we have going on at the top here? Well, to create that interface, we're actually going to want to head inside of index.html. And we're going to start laying this out like a real HTML document. So I'm going to wrap our canvas tag and also our script tag inside of a body tag. So we know that these are our body elements. And basically what we want to do is we want to wrap our canvas tag in one large div. This is going to be our container div. So this div that we just created is going to represent the full width and height of our canvas all the way from up here to down here. And we want to go ahead and place all of our elements inside of this one large div because all these elements need to be relative to the div we just created. We don't want our elements relative to something like our browser window, otherwise they might be placed somewhere like down here outside of our canvas. We want to make sure they're always placed within our canvas width and height, which is why we're wrapping everything in that one div. Now within this div, we also want to place one more div inside of it. And this is going to take up the full width of the parent div, but it's also going to be the location in which we want to put our health bar and the timer right here. So we're going to add one more div inside of that div we just created, and this div right here is equivalent to this red rectangle that extends full width that we just created. So what's within this one smaller red rectangle? Well, we have one rectangle here, we have one rectangle here, and we have one rectangle here. So essentially we're going to be creating 3 more rectangles inside of that div we just created. So over here inside of this div we'll add 3 more. 1, 2, 3. This first one is going to be player health. Last one is going to be enemy health. And the third one is going to be the timer. So to start styling these divs, let's go ahead and add a style attribute onto these. And here we're just going to write inline styles to do this because it is the easiest method. So our styler right here is going to be equal to background-color. This changes the background color of whatever div we're currently on. We're going to assign this to yellow to make sure that we get this yellowish color for the background. This is what we're creating, by the way. It's just this one rectangle right here with the red inside of it. With our background color equal to yellow, we can go ahead and give this a height of something like 30 pixels. And if we give this a width of something like 100 pixels, let's go ahead and see what this looks like. Let's save. Go back over here and refresh. You're going to see we just created the beginning of our health bar. Perfect. We're going to notice that the health bar right here is pushing our canvas down, but we don't want that. We want that overlaid on top of our canvas. What this means is we need to select the main container div right here. That's going to be the largest red rectangle, and we need to add a position of relative on top of that. That's going to be the first requirement. You're going to see why I'm doing this soon enough. So this is going to be the red container div. We can even comment this out, red container div, to help us out in our code a little bit. And within this div, we're going to add a style attribute. And here we can go ahead and add a position of relative onto that. So if we were to save and refresh, nothing's going to change by default, but we do need this in place to get the effect we're going for. So now we're going to be able to get this yellow health bar on top of our canvas. How are we going to do that? Well, what we can do is we can select this child div inside of it. This is the smaller red container div. We want to go ahead and select this, add a style attribute on top of it, and give this a position of absolute. So if I save that and refresh, now by default this is on top of our canvas. So whenever a child element like this has a position absolute, basically what that means is we want to take it out of the document flow. When it's taken out of the document flow, other elements such as our canvas element right here aren't going to be affected by the width or height of that one individual element. So we gave it a position of absolute, and since it's container div, the large red rectangle that's containing the whole canvas has a position of relative. Basically what we're saying is this element with a position of absolute should be relative to that main container div with the position of relative, which it is now because that container contains our entire canvas. It's drawn in the top left hand corner of where that container div begins. So perfect. Now before we make this the correct width, let's go ahead and draw our timer box in there. It's going to be focusing in on this div right here, right below timer. We're going to add in a style, give this a background color of, let's just say, red to start. We're going to give it a width of 100 pixels and then a height of 100 pixels as well. So we save that and refresh. This is going to be the container div for our timer. So obviously this is placed beneath our health bar right here when it should be next to it. So how do we move these two divs next to each other rather than placing them on top of each other? Well, by default, if we go ahead and look at these two elements right here within our inspector, we see we have our health bar div and we have our timer div. And if we look down below, by default, divs have a display of block. What does a display of block mean? Well, it means that elements are laid on top of each other like blocks. They're stacked on top of each other. So by default, a div is always going to be stacked on top of another div. But the thing is, if we go ahead and add a display of flex to the parent div, then these divs are going to be placed next to each other by default rather than stacked on top of each other. A parent div with a display of flex affects all elements within that parent div. So we're going to go ahead and find our parent div for these two elements right here. That parent div is going to be this one with a position of absolute. We're going to add a semicolon to the end of the style and then add into this a display style equal to flex. So now that this parent has a display of flex, it's saying take all the children elements and place them next to each other by default, even if they have a display of block. So we save that, refresh over here, you'll see now these elements are next to each other. Perfect, we're getting closer and closer. Finally, let's go ahead and add in our enemy health. To do this, I'm simply going to copy this div and paste it right beneath enemy health. Save and refresh, and we're getting closer and closer to the style we're going for to match up with what we should have right here. Now this display flex that we just added is pretty magical because there are a bunch of subclasses that work in tandem with display flex. So by hovering over this div, you'll see that it doesn't take up the full width of our canvas. We definitely want to make sure that it takes up the full width, simply because we want our health bars to expand so we can see the exact amount of health either our player or our enemy has left. So by selecting this element within our browser right here, we can test this out temporarily to see what this would look like with a width of 100%. So as soon as I give this a width of 100%, we don't see any changes, but if we hover over this, you'll see now the div is taking up the full width of the canvas. That is perfect. That is what we want to start, because if the parent has a width of 100%, it's going to allow our children elements to grow based on our needs. So adding a width of 100% right here in the browser is just temporary. If I'm going to refresh, you're going to see that width disappears. So we do want that width on that element that we just placed it on, which is going to be the one with position absolute and display flex. We want the width of this to be 100%, so we'll add that in right there. Save and refresh. You'll see that takes effect permanently. And now we can begin affecting the actual widths of our health bars. So we don't want a static width of 100 for our health bars. Right now they're equal to 100 pixels. We just want to make sure that they take up the full remaining space of our actual canvas. So right here where we're using width of 100 pixels, we're no longer going to define this as 100 pixels, but rather 100%. We save that, we refresh, And now you'll see right here, this player health div is taking up 100% of the remaining space. The thing is, we can equal this out with our enemy health by changing our width right here of 100 pixels to 100% as well. We save and refresh that. And now you'll see these are taking up an equal amount of space because both of them have a width of 100%. And they're also inside of a div that has a display of flex. Now by adding that width of 100%, you'll see that our timer div right here, even though it has a width and a height of 100 pixels, well now it looks to be at 47 pixels wide rather than 100. So by default, flex elements will shrink based on their neighboring elements. Since their neighboring elements have a width of 100%, and this one has a static width, this one element is trying to shrink to accommodate for all that other space that is being taken up. If you don't want a child element within a parent that has a display of flex to shrink, here's what you need to do. You need to select the element you don't want to shrink, and then add in a style called flex-shrink, and you're going to set this equal to 0. So if you set this equal to 0, 0 basically means false. It says do not shrink this. You can save that and refresh. You'll see now that it's correct size, it's no longer shrinking, simply because we set flex shrink equal to 0. So now let's go ahead and get our health bars in the middle of our timer to represent more of what we have over here within our initial design. So to get those centered, we're also going to be adding on an additional flex property. This one is going to go right next to display flex on the parent. So this style is going to be called align-items. So this style right here only works if the element has a display of flex. If we were to get rid of display flex right here, align items would not work at all. You need to make sure that it has a neighboring display flex in order for this to work. What is something that we could set align items to? Well, center. Basically what this says is we want to take all the items within this div, going to be these 3 divs right here, and we want to align them vertically in the center of this parent div right here. So by adding align item center, we're going to center all the children vertically. Let's go ahead and save that and refresh. And you'll see those children elements are centered vertically. We're starting to look even closer to our design over here. So now it's important that we see what this looks like without the inspector open. So we're going to go ahead and hit the X right here. And you're going to see, well, that definitely looks wrong. So let's go ahead and fix this. I'm going to go back to inspect element, but I'm going to move our inspector to the bottom. Now I can see exactly what this looks like and can figure out what is going wrong. So if I hover over this div right here, you'll see it's taking up the full width of our browser window. If I go up one higher, this is also taking up the full width of the browser window. We only want this taking up the full width of our canvas. And the reason this is taking up the full width of our browser window rather than the canvas inside of it is because a div by default has a display of block. A display block element takes up 100% of the parent div, which in this case is going to be body, which is also the full width of our screen right now. So we don't want a display block to this div. What we want to use instead is going to be display is equal to inline block. An inline block means that the element can still stack on top of other elements, but it's only going to take up the full width of whatever children are inside of it. So this child right here, this div that contains our health bar, has a position absolute. It doesn't actually affect the width or height of this parent div right here, but this canvas element has a display of block, so it does affect the width and height of the parent element. As a result, when we put a display of inline block on this parent element, it's saying that it should only be the full width and height of the canvas that's inside of it. So that's all we have to do within our code, is find our parent div, which is going to be right up here, and then add in a display of inline-block. So if I save that and refresh, now you'll see this is within our canvas. Even when I exit out of our inspector, it's in the correct spot. It's starting to represent our health bar even more accurately. Now, before we start subtracting from our health bars, I think it makes sense to add some padding around this just to give it a little bit of breathing room from the edges of our game. So we want to go ahead and add padding into our health bar, while we'll grab our small red container div. And here we can add in a property of padding. And here we're going to set this equal to something like 20 pixels. When we set this equal to 20 pixels, we're putting 20 pixels of padding on every side of this one container. So we want to go ahead and make sure we save that. Go back over here and refresh. Now you'll see we have padding all around this. But you'll notice that adding the padding here is pushing our box outside of our canvas. We just added around 40 pixels of padding onto the overall width of the container, which means it's being pushed out. Well, something that we need to do in order to fix this is we need to add in a custom style that says we don't want our overall width affected by our padding. So to do this, we're going to create a head tag above our body tag. This is where all your site's metadata typically goes, but inside of here we're going to add in some style tags. And now we can go ahead and begin writing some more traditional CSS. The CSS we want to write is going to start with an asterisk, and then an opening and closing curly bracket. This asterisk means we want to go ahead and apply the following style to every single element within our web page. What style do we want to apply to everything? Well, it's going to be box-sizing, and we're going to set this equal to border-box. So if I save this and refresh over here now, you're going to see that this is aligned correctly. Why? Well, by adding that border box property, padding is no longer going to be taken into effect when calculating the width of elements. You should pretty much always have this on every site you create. I don't know why it's not on browsers by default, but you pretty much always want that there to make sure that your padding isn't messing up the overall width of your elements. So that's all we have to do to make sure that we have padding in place to give our interface some breathing room so we can begin subtracting health from both our player and our enemy. So now whenever our player hits our enemy, let's go ahead and start subtracting from our enemy's health bar up above. To start subtracting from this health bar, we're going to want to go ahead and add an ID onto it. So right here, this is our enemy health. We can add an ID onto this div by declaring our ID should be equal to some sort of string. What is a good identifier for our enemy health? Well, no other than enemy health like so. This is how we're going to reference it within our JavaScript. So now we can head over to index.js and start on scrolling down to where our enemy gets hit. So this right here is where our player is attacking. This means our enemy is getting hit. Instead of console logging out to go, we're going to go ahead and select our enemy health bar. We can go ahead and grab that health bar with document.querySelector, and then we're going to select the ID we just created. It's going to be indicated by a £. That's how we select an ID. And then the name of the ID, which is enemy health. And here we want to select the style on this, specifically the width. And now when our enemy gets hit, we can set this equal to something like 20%, and that should shrink the health bar down from 100 to 20%, just to illustrate how this is working. So I save this, and refresh, move over, and then hit our enemy. You're going to see, well, the width of this definitely shrunk down to 20%, but it kind of just looks like our timer moved over to the right because of this new change. So we want to take this into account when styling these health bars. Right now, the positioning of our timer is dependent on the width of these health bars in the background. Let's go ahead and refresh, get that back to its original position. What we're going to need to do is add in a new div that is not part of this little mini layout we have going on here. This new div is going to have a position absolute, and it's essentially going to cover the full width and height of one of these health bars. So since this new div is no longer part of the layout, when we change the width of this div with a position absolute, well, it's no longer going to push everything around. Just this one div is going to be shrinking as a result. So let's go ahead and add in that position absolute div. We're going to go back on over to index.html. And to add in a position absolute div right beneath enemy health, we'll add in a new div, give it a style of position absolute, like so. We'll say the background here is going to be equal to blue. So since we're using a div with position absolute, we want to go ahead and wrap these two divs right here inside of a parent div to make sure this position absolute div can be relative to the parent. So for the parent, we're going to add on a style of position relative. And then since this parent div is now going to be responsible for pushing elements around, it's going to be responsible for our layout. We want to make sure that we declare for the parent div, this is where the width and the height should be 100%. So I'm going to copy these two styles right here. Well, at least cut them out, not copy. And then I'm going to paste them in within the parent style tag. So if I save that and refresh, we lose our health bar over here, but that's totally okay. That's actually what we want in order to get this working correctly. You'll see if I right click and hit inspect and hover over that div we just created, this is what it looks like, which is perfect. It represents our health bar, but if we look inside of our children elements right here, well, they don't take up the full width and height of this parent div like we want them to. So our current enemy health right here has a width of 442. That's great, but it doesn't have any height associated with it. So if we want to go ahead and make sure this has a height associated with it, we can just make it the same height as the parent by adding in height 30 pixels. And that should show this div again. We save that and refresh, and indeed it is back. But now, when we select our enemy health down here that has a background color of yellow, this div right here, if we begin affecting this width instead, set it to something equal to like 90%, you're going to see that decreases over time. So let's go ahead and refresh our game, and then we're going to attack our enemy. We hit space. You're going to see that shrinks down to 20% immediately. That is great. But one thing is, we don't know the full extent of our health bar because we don't have any background div right here saying, well, how much health was there to begin with? You'll see this a lot in traditional fighting games. There should be some sort of background div right here indicating how much health was there originally. We actually set this up by adding in the second div right here with position absolute and a background of blue. So we want to make sure that this div right here takes up the full width and height of this parent div with a position and relative, And to do this, we can go ahead and say that the top style is equal to 0, that the right style is equal to 0, that the bottom style is equal to 0, and then finally that the left style is also equal to 0. So I save that and refresh. Well, now we see our blue element is overlaid on top of our yellow. Basically what top, right, bottom, and left indicate are how far from the parent div should this rectangle be placed. So we're saying that the top of this rectangle we're creating should be placed 0 pixels from the top of the parent div, 0 pixels from the right of the parent div, 0 pixels from the bottom of the parent div, and 0 pixels from the left of the parent div. And by doing that, we're basically just saying for this position absolute element, take up the full width and height of the parent. So if this element's going to be on top, this is actually what we want to subtract to show our player's health decreasing. So what we're going to do is we're going to move this ID right here from this first div onto the second div, which has a background of blue. We'll go ahead and paste that on in, save and refresh, and then when we hit our enemy, you're going to see the blue div decreases, but the yellow stays in the background. The yellow is just going to be the full indicator of how much health is there, while the blue is going to be, well, how much health do we have currently? That's exactly what we want. But we don't want to be decreasing this so that this goes directly down to 20%. We want to make sure that this decreases over time based on how many times we hit our enemy. So back within index.js, we don't want to go down by 20%, but rather by the enemy.health. So if we're going to use a property called health, we need to make sure that we're adding that on to our sprite class up above. So we'll go ahead and say that this .health is going to be equal to 100 to start. So our enemy and our player are going to have 100 hit points to start. And then back down here, whenever we hit our enemy, we need to make sure that we select our enemy.health and we subtract from it a value of something like, let's just say 20. So for each time we hit our enemy, we're going to subtract 20 hit points from enemy.health, and then we're going to set our health bar equal to that new percentage. But if we want to set this equal to percentage, we need to make sure that we add on a string of %. And now when we save and refresh that, if we begin hitting our enemy, you're going to see that decreases incrementally over time. So now let's go ahead and do the same thing so that when our enemy hits our player, the player health bar decreases as well. We're going to go ahead and use the same methodology that we used before for our enemy. All we need to do here is simply copy our enemy health divs all the way down here, and we're going to go ahead and replace our player health with those divs. The only thing we really need to change is the ID. We're going to change this to player health, but this is going to set us up for success to use the same technique that we just had prior. So now that we have an ID of player health right here, we can go into index.js, and we want to detect for collision when our enemy is attacking. It's going to be right here. We can simply copy this line of code and then paste it into when our enemy is attacking and say we want to select not our enemy health, but our player health instead, and then set the width equal to not the enemy health, but our player health as they get hit. So we do need to subtract our player health each time our player gets hit. So to do this, we can copy this line right here, paste it down below, and then say that each time our player gets hit, we want to subtract our player health by 20. And with just this, let's go ahead and see what happens. Let's refresh. Then we're going to take our enemy and hit our player. And you're going to see that decreases over time, though it is in the wrong direction. We want to make sure that this decreases from the left to the right, rather than from the right to the left like we did for our enemy. So to get this moving towards the right instead of towards the left, we're going to select the parent div right here and set its display equal to flex. Once we do that, we can say for all the children elements, we want them aligned to the right. So that's what we're going to do to get this effect, is we're going to select that parent div over in index.html. That's going to be this div right here. We're going to add in a style of display flex. So I add that in, save and refresh, still looks the same. And if I go ahead and tag our player, still the same functionality, although our yellow health bar is gone. That's totally okay for now. We just want to make sure that this is going in the correct direction. So if we want to align this to the right over here, since we have a display of flex on this parent div, we can add on a subflex property called justify-content. This only works if you have an element with a display of flex. So now that we have this, we can say that we want all children elements to go to the very end of this container by adding in a property of flex-end. So once we say we want all of our children elements aligned to the right, all we need to do now is get rid of left equal to 0, because we don't want the left-hand side of this div always touching the left-hand side of the parent div. We want this to decrease over time. So we're going to go ahead and get rid of left. And then we want to set our width right here equal to 100% by default. So if I save this and refresh over here, everything still looks the same, but as soon as I hit our player, you're going to see that starts to decrease in the correct direction because the parent div has a display of flex and its justify content is set to flex end. But we are missing that background element now. All we should have to do here is add in a width of 100% to this div with a background color of yellow. Can save that, and then hit our player a few more times. You're going to see that stays in place. That looks great for our player. When our player fights back, that looks great for our enemy. So with that, we're going to be able to check off our health bar interface. So let's take care of game timers and game over functionality. So basically in our game over here, we're going to put a timer right in the middle of this red box. It's going to decrease over time, and then eventually when it hits 0, depending on who has the lower amount of health, we're going to go ahead and determine who won and then display some text in the middle right here that says either player 1 or player 2 won. So to add that functionality, the first thing we need to do is head inside of index.html, and we need to find where our timer is. It's going to be right here as indicated by this timer comment. And inside of this div, we can go ahead and insert a time. So we're going to say our game is going to be 10 seconds long to start, simply because we want to go ahead and test this pretty quickly, relatively quickly at least. So with 10 seconds inside of here, we'll save, we'll go back to our game, refresh. There is our timer. Let's go ahead and make sure that this is centered right in the middle of this red square. To center this, we're going to go ahead and add a display, a flex, onto this div right here. And then we want to go ahead and use some of those properties we were using earlier, including align-items. This is going to be equal to center. That means we're going to center the text inside of this vertically. We can save this, and then refresh to see how that looks. And that is indeed centered vertically. Now we just need to center this horizontally. So to center this horizontally in the exact same location, all we need to do is add a justify content style, and we're going to go ahead and say that we want to justify our content in the center. This means we're going to align our content in the center of our container on the x-axis. So we can save that, go back to our game, and now that is in the correct position, so perfect. So let's start getting this timer counting down towards 0. To do this, we want to make sure that we can select this div within JavaScript, and to do that, it makes sense to add an ID onto this div. This is going to be called timer. Simple enough. And now that we have an ID on this, we can head on over to index.js, and we're going to create a function right above animate that is responsible for decreasing this timer as time continues. So this function is going to be called decrease timer. Whenever we call this function, we want to go ahead and decrease this number by 1. So to do this, we need to start with a variable. We're going to create a let called timer and set this equal to 10. That is the time we currently have over here. So now that we have timer equal to 10, each time we call decrease timer, timer is going to subtract 1 from itself. But we should only be subtracting 1 from itself as long as timer is greater than 0, because we don't want to get into negative values. So right now what we're saying is, if timer is greater than 0, we're going to subtract 1 from it, but we want to make sure that this is occurring over and over again. And to get this called multiple times, we can go ahead and call set timeout inside of this. Make sure you have a capital T for the second T right here. And then what function do we want to call? We're going to call the same function that's right here. It's called decrease timer. So basically we're creating an infinite loop. It's basically the same thing as we have down here within our animate loop with request animation frame. We're just looping through this. Set timeout is going to be the same thing, but we can go ahead and determine what interval do we want set timeout to be called as the second argument. So the second argument right here is going to be in milliseconds. So this basically just creates a loop right here for our function, and we can go ahead and test this out simply by calling decrease timer right beneath it. So if we call this out, save, and then refresh, we're not going to see anything actually, because right now this is only programmatic. Our timer is decreasing, but we can't see it unless we console log it out. We need to associate this with the label we actually have inside of our red square right here. So to get that association, we'll also say if timer is greater than 0, we're going to add some brackets right here so we can write multiple lines of code. We're going to subtract 1 from timer, and then we're going to go ahead and select our document, get our query selector, and then what do we want to select? Well, let's look within index.html. We just created an ID of timer, so let's go ahead and grab that with a pound sign, and then we'll select timer, and then we could say the inner HTML for this element. So whatever is inside its element right now is just the text 10. We want to go ahead and set this inner HTML equal to the timer that we're currently subtracting. So as long as we have this code right here, we save it and then refresh, we're going to see that this decreases over time for every second until we get down to 0. And once we get down to 0, we should see this stop, and we should not proceed into negative values, which indeed we stop at 0, we are good to go. So looking back at our code, it really only makes sense to continue calling setTimeout if timer is greater than 0, otherwise there's really no point. So also I'm going to go ahead and add this inside of here. And then right beneath this if statement is where we're going to determine who won. Is it going to be player 1 or player 2 that actually won the game? It's going to be dependent on who has the most amount of health. So right beneath this if statement, we can write an additional one that says if our player health is equal to our enemy health, then what happens? Well, we know we want to go ahead and say that there is a tie. If they have the same amount of health when the game ends based on the timer, we're going to have a tied game. But it doesn't really make sense to console log this out because someone playing our game is not going to have their developer tools open. At least they probably won't. So we need to create some sort of label that we can change and display onto our game. So within index.html, we need to find a good location to put some sort of display label. And I think a good place to put it is right above our canvas because I don't want this associated with our health bar user interface. I actually want this right here in its own separate container. So I'm going to create a div right above canvas, and then inside of this I'm going to go ahead and write out tie. I just want to go ahead and see where that is. So I save that, and I refresh, and it's going to be placed up here by default. But we can get this on top of our canvas by making this have a position of absolute. So let's go ahead and do that next. On this div, we're going to add on a style tag and say the position here should be absolute. And if we go ahead and make this absolute, if we look at this text, it's currently black, and our background is black for our canvas. We need to make sure that we have some contrast here by changing our text color equal to white. So right after the position, I'm going to add in color and set this equal to white. So I want to go ahead and save that, refresh over here, and now tie is overlaid on top of our canvas. But we might want it centered directly in the middle, so we need to write a little bit extra code right here. To do this, what we're going to do is we're going to add a display of flex on this element. And can you tell me what comes next? Well, we want to use aligned items, center to get this centered vertically, and then justify content center to get this centered horizontally. So you might think if I save this and refresh, it's going to be right in the center, but unfortunately it is not. Let's go ahead and inspect this. I'm going to go ahead and right click, hit inspect element, and then I want to inspect our tie tag right here. So if I look at this div with a position of absolute is not taking out the full width or height of the canvas. Right now it's only taking out the amount of space of the text inside of it, which is just tie. But our canvas is a full width and height right here. So we need to make sure that this div takes out the full width and height of the canvas as well. And in order to do that, since we have a position of absolute, we can go ahead and add on the top, right, bottom, and left properties to say that we want the top, left, bottom, and right of this one div to expand the full width and height of the parent container. So to do that, we're going to say top is equal to 0, right is equal to 0, bottom is equal to 0, and then finally left is going to be equal to 0 as well. So let's save that and refresh over here. And now we're going to see that tie is directly in the center because now our div starts from 0 from the top, 0 from the right, 0 from the bottom, and 0 from the left of our actual canvas. This is looking to be in a great spot right now. So we don't want this showed by default. You'll see right here when I'm refreshing, we see the text tie. Let's go ahead and hide this. I'm going to give this a display of none. And if we give this a display of none, we need to make sure that we delete display flex right here because we don't want to show this at all right now. We'll keep everything else. But as long as this has a display of none, we're going to see that's hidden and that doesn't get in the way of anything. So the next thing we want to do is head over to index.js. And when our player health is equal to our enemy health when our timer runs out, then we want to go ahead and select that text. To select that text, we're going to use document.querySelector, and then we need some sort of ID to select that one div. So within index.html, we need to add an ID right here. We can go ahead and call this ID display text. And this is what we want to go ahead and change back within index.js. So we can select this with a £, get display text, and then we want to change the inner HTML equal to tie. Not only do we want to set this equal to tie, but we also want to select it again. So I'll go ahead and copy this line right here and set its style, specifically its display property, back equal to flex. So we're no longer hiding it when this is true. We're going to set it equal to flex. It should indeed display when the time runs out. So to make this a bit quicker, let's go ahead and decrease our timer to 5, save our code, and then refresh over here. We're decreasing downwards, and it looks like we're already showing tie right here. That's not exactly what we want. We need to make sure this if statement only fires if timer is less than 0. So technically what we need to do, we need to make sure that this text right here only shows if timer is actually equal to 0, not for each iteration of decreased timer. So we can go ahead and wrap all of this in an if statement that says if timer is actually equal to 0, then we want to call the following code. So we save that, and let's go ahead and test this. I'm actually going to go ahead and hit the enemy right here. You'll see that decreases. And now we're no longer showing that text because the health bars are no longer equal. This conditional right here is just not true, so we're not going to fire these 2 lines of code. So now we need to take into account what happens if a player's health is greater than the enemy's health. We can write an else if right after this that says if our player health is greater than our enemy dot health. Well, we want to show some different text. We're going to select these 2 lines right here and paste them in below. And instead of saying that our inner HTML should be equal to tie, we're going to say player 1 wins. Now, this code right here is duplicative of the code above when we're setting style display equal to flex. If we see some duplicate code like this, what we can do is we can simply take it out of the location where it's being used. I'm going to cut it out right here and paste it in a location where it's only going to be called once. So when timer is equal to 0, I know I want to show our display text, but then based on whether our player health is equal to enemy health or greater or less than, that is when we're going to change what text is actually inside of this div. So we can also delete that other query selector with style display equal to flex right here. And now we saved ourselves 2 lines of code, made it equal to 1 instead. So let's test out what happens when player 1 wins. We'll save this, refresh, and now we need to hit our enemy. And our enemy's health decreases. And now we're displaying the text, player 1 wins, simply because player 1 has more health than our enemy. Now we want to do the same thing for when our enemy wins. So we'll simply add in another else if statement right here and say when our enemy health is greater than our player health right here, then that is when player 2 wins instead. So we'll save and refresh, and then I'll hit our player with our enemy. Now our enemy is going to win. Now player 2 wins. So great, that is perfect. So we're looking to be in good shape with the timer, but what happens if our enemy or our player decreases one of the other's health down to 0 before the timer runs out? We need to write some code for that to tell what happens. So we're going to go ahead and increase our timer to something more standard like 60 seconds. That way this doesn't actually call before we're ready. So we refresh with that and you'll see this starts decreasing, and now we have 60 seconds in order to end our game based on health rather than the time running out. So when we go ahead and get our enemy down to 0, then we want to go ahead and display that same text that we were showing earlier for when our timer ran out. So to monitor for that, we're going to go inside of our animation loop. And this is going to go beneath where we're detecting for a collision for both our player and our enemy, because we know these are the 2 places in which we are decreasing our enemy and our player's health. So beneath this second if statement, we're going to go ahead and end the game based on health. And we want to say if our enemy dot health is less than or equal to 0, or our player dot health is less than or equal to 0, then we know our game should be over and we should show some certain display text right here. So to determine what text we should display, basically what we can do is we can go ahead and change this conditional into its own function and then call that function down below. So let's go ahead and refactor this a little bit. We're going to add a new function above decrease timer that says determine winner. This is going to take, well, 1 argument. It's going to be an object with 2 properties inside of it. What are the 2 properties? Well, it's going to be our player and also our enemy. And now that we have these 2 in place, we can go ahead and call this code right here. So I'm going to cut it out of this location, simply paste it in determine winner, and now we can go ahead and use determine winner in that exact location where we just cut that code out. So right here, we're going to call determine winner. We know this takes 1 argument. It's going to be an object with a player and an enemy property. So I'm going to add player right here and enemy right here. And now based on whether or not our player health is equal to our enemy health, we're going to show tie, or player 1, or player 2 wins. It's just a nice little abstraction to make our life a little easier when we want to do the exact same thing down below within our animation loop. So if enemy health is less than 0, or player health is less than 0, then we know that we should be calling determine winner right here. This also takes an argument. It's going to be an object with a player and an enemy. And based on all this, we're going to go ahead and display that text that we were showing prior with our timer. Now before we actually go ahead and save and refresh, let's go back up to determine winner, and we just want to make sure that we also put this code inside of it right here. That sets our style display equal to flex, otherwise it's not going to show. So within determine winner, we're going to go ahead, paste that in, and now when we save and refresh over here and we be up on player 2, eventually when we get them down to 0, you're going to see now player 1 wins. We display the correct text. So same deal. Let's go ahead and beat up player 1 now. Get them down to 0. Now we know player 2 wins before the timer runs out. We still have our timer functionality in place. Although, I suppose when either player 1 or player 2 wins, we need to make sure that we stop this timer altogether. So let's do that next. So to stop a timer, we need to get the timer ID that's returned from setTimeout. So we're going to create a let right beneath timer called timer ID. And we don't actually need to assign this to anything by default, but when we're calling setTimeout, we're going to go ahead and say timer ID is equal to the return value of setTimeout. So for each time we call setTimeout, this is going to return a number. It's going to be either 0, 1, 2, 3, and it's just going to keep increasing over time. That's going to be the timer ID. And since we associate that with this let of timer ID, we can use this to cancel our loop altogether to make sure that we're no longer calling decreased timer. So with inDetermineWinner, we're going to add in an additional argument. It's going to be timer ID. And then as the very first thing right here, we're going to call a function called cancel timeout. And it's going to take that timer ID that we passed through. So we just make sure we're passing this through within determine_winner right here. We're going to pass through timer ID, and that's going to prevent this from being called when our timer runs out, but we need to do the same thing down below within our animation loop. So when we go ahead and determine a winner right here, we're also going to pass through the timer ID. So we'll go ahead and save, and then refresh over here, and then be up on player 2, get them down to 0, and it doesn't look like it's stopping. So let's go ahead. And whenever this happens, you always want to go ahead and right-click, inspect element, and then see what's happening in the console. Looks like cancel timeout is not defined. It's a dumb error on my part. Let's go ahead and find where we're calling cancel timeout. It's going to be within determine_winner. It's not actually cancel timeout. I don't know why this is the first thing that comes to mind for me, but it's actually going to be clear timeout instead. Just a little bit of a syntax difference. So we save that, we try again over here, get out of the console, and then be up on player 2 one more time. You're going to see that stops completely because we called clear timeout correctly. We also show player 1 wins, which is great. We can test the exact same thing for player 2 when they win. We're going to see that stops completely, and we're still displaying the correct text. So perfect. And I think with that, we can go on over to To-Do and check off game timers and game overs. We just created the basic functionality that we needed to get a basic fighting game set up. So now we're going to go ahead and move on to sprites and animations. So we're going to be inserting images into our screen and also animations for our characters, our background, and a little bit of our UI. So we're going to go ahead and start off with our background sprite. What is a background sprite? Well, it's going to be simply an image we put in the background like this. Although this is not what our game currently looks like. Currently looks like this with just a black background. So we want to go ahead and get that image into our game. How would we go about getting this image in the first place? Well, over on itch.io, this is a website specifically for game assets, and a lot of these assets are free, provided to us by really talented authors, such as Brulov right here. I went over to itch.io and I went into the Oak Woods Environment Asset Pack. So this is completely free to use on personal and commercial projects. If you want to go ahead and download this yourself, you can go ahead and hit download now. And I would really recommend leaving a donation for the author because they definitely put a lot of effort into creating this artwork. But if you just want to download this for free, you can click this right here. And it's going to lead you to the downloads. You just click download. And it's going to go ahead and initiate your download. So I already downloaded this, and all the assets I want to use in our game actually moved into a folder within Finder. It's going to be called Fighting Game Assets. So you see we have a folder for a character named Kenji, a folder for a character named Samurai Mac, and then a background, and then a shop. So this is going to be available to you within the Google Drive link within the description of the video. But the main thing we want to focus on right now is going to be background.png. So you'll see I took this image from the asset pack and I resized it down to 1024 by 576. So it's going to go ahead and fit our screen perfectly. It's going to cover up the whole black background. If we want to go ahead and use this in our game, what we're going to do is we're going to simply select all the assets within this folder. I'm going to select shop, hold shift, and then I'm going to click on Kenji to make sure that I select everything. And then I'm going to hit Command C to copy these. It's going to be Control C if you're a Windows user, but once you have these copied, you can head back to your web directory or wherever you stored this project. I'm going to go inside of Fighting Game, and then inside of here I'm going to create a new folder called IMG for images, and then I'm going to paste that in by hitting Command V, Control V if you're a Windows user. So that's going to go ahead and paste these within our project, and then if we look at Sublime Text, you're going to see that we have an image folder with all those images available to us that we can now use within our code. So we want to go ahead and make use of background.png right here. How would we go about inserting that into our game? Well, I made this sprite class for a reason. I want to use this class not just for our fighters, but also for our background images, our shop image, whatever it may be. But at the same time, this class currently has a lot of functionality related to a fighter, rather than just rendering out a simple image onto our canvas. As a result, it kind of makes sense to refactor this class into a separate class. We're going to keep this as is, call it Sprite, but we're also going to create a class called Fighter, which is going to resemble our player and player 2. So what we want to do here is basically duplicate our class all the way down to the very bottom. I'm going to copy that and paste. And then I'm going to call this class Fighter. So this is actually going to be the class that we use for player 1 and player 2. But this class up here of just Sprite, we're going to go ahead and refactor this. So this is just responsible for rendering out an image. So if we go ahead and look at this class of Sprite, what do we need and what do we not need? Well, we know a Sprite is not going to have any attack method associated with it. So we can go ahead and delete that. Within update, well, what does a sprite need to do over time? Well, it's going to need to update its frames if we want to add in some sort of animation. But a lot of this is related to our player's attack and gravity. We don't want any of that. We just want to go ahead and make sure that we're drawing this, and we're going to be using update a little later on to update the variables associated with each of our sprites. If we scroll on up, we have draw right here. Now, what does a sprite look like? Well, they're not going to be rectangles because we're actually drawing out images onto our screen. We don't need anything related to drawing out rectangles. We're just going to delete all this. We're going to go ahead and edit this within this individual lesson. And then if I scroll on up, what else do we not need for a sprite? We can get rid of health because sprites are not going to have health. That's going to be related to our fighter. Is attacking is also related to fighting. We don't need a color because we're going to be using images. We do not need an attack box. We can get rid of that. We don't need a last key, but we do need a width and a height associated with our image, at least later on. So we're going to leave this right to now. And we don't need a velocity either, because these aren't going to be moving around the screen, at least not yet. That's mostly going to be just our fighter down here. So with all this in place, what do we need to get rid of within our constructor argument? We get rid of velocity, color, and also offset. So we just have a very basic sprite class at the moment. So we added this class in, and now we have a class of fighter. And it's kind of muddying up our code a bit within index.js. We have our design in here, but we also have code related to our game implementation. So it kind of makes sense at this point, if you're having trouble finding certain things within your file, to refactor this into a separate file. And that's exactly what we're going to do for code maintenance purposes. So what I want to do is I want to go ahead and make sure that our classes are in their own separate class file. In order to do this, I'm going to go to File, New File, and then I'm just going to hit Command S to immediately save this. And then I want to save this as classes.js, but I'm not going to save this within our root. I'm actually going to go ahead and create a folder called JS. All of our new JS files are going to go inside of here. So I'm going to save that. And now we have a folder of JS with classes.js inside of it. So great. Now we can go ahead and select our classes. Go with class of Sprite all the way down to class Fighter. I'm going to cut these out with Command X. And then over in classes.js, I'm going to paste that in with Command V. I can hit save. Save on index.js as well, but this isn't going to work if we save and refresh everything, because we need to make sure we're pulling in classes.js into index.html in order for that file to be read. So we want to make sure that we pull this in before index.js, and we want to reference classes.js. So in order to do this, we need to go inside of our JS folder, and then reference classes.js. So now our classes within this file right here are going to be available to us within index.js. So we save this, we want to go back to index.js, and here you'll see that we're currently creating our player and our enemy from our sprite class. We know we created within classes.js a new fighter class. That's what we want to reference for our player and our enemy. So here we're going to change new sprite to new fighter for both our player and our enemy. And if we save everything, index.js, index.html, and classes.js accordingly, if everything went well and we refresh over here, well, we have our player and our enemy in place, and everything still functions as expected, so great. So now that this is cleaned up a bit, definitely makes it a little easier to focus on what we need to focus on. So within classes.js, we want to focus in on this class of Sprite. So Sprite, like I said, is just going to be an image, and it can be animated over time, but we're going to do the most basic one, which is just going to be a static image to start. So in order to render an image on the screen, what we're going to do is whenever we create a new sprite, we're going to pass through an image source, so src. And we're going to use this image source to create a new image whenever we create a new instance of Sprite. So we're going to create an image property called this.image, and to create an image within JavaScript, we can use a native API object called newImage. So this basically creates an HTML image, but within a JavaScript property such as this.image. And once we have this available to us, well, we need to set this.image.source equal to the source of the image we want to actually show. So that's going to go ahead and store the image within the property of this .image, but if we want to go ahead and draw this out, we need to use a canvas function within our draw method right here. So the canvas function we're going to use is going to be c.drawImage, like so. So the first argument here is going to be an HTML image element, and that's already created for us right up above with new image, stored in this .image. So that's going to go right here as the first argument, this .image. And then for our second argument, we want to go ahead and add in an x-coordinate. Thankfully, we set this up already when we were creating our fighter class and duplicating this. So we can get the x-coordinate with this .position.x, and then we need a y-coordinate, which we can get with this .position.y. This is all we need to do to create an image and draw it out on the screen using Canvas. So we save that. Now, within index.js, we need to do the actual implementation for this class. So we can either do this above our players, beneath our players, doesn't really matter. I'm going to do it above them. I'm going to create a new const called background. I'm going to set this equal to a new sprite. So this is going to take one argument with a few properties inside of it. What properties does this take? Well, it's going to take a position. So we'll put in position for our property. Position is going to be equal to an object with an x and a y property. So what is the x coordinate of this background? Well, I want it to start at the very top left-hand corner of our screen. So that's going to be 0 for x and also 0 for y. Now, what else does a sprite class take? Well, we can always look within classes.js. We see it takes a position and it takes an image source. So now we just need to add in an image source attribute, and this is just going to reference the file location in which we want to put on the screen. So it's going to be a string, and from index.js, how do we get background.png right here? Well, we need to go inside of img, and this / right here just means we're starting within the directory of index.js. So we go from this directory, we go inside of image, and then we need to reference background.png. So background.png. So we want to make sure we save that. And now we have a background sprite in which we should be able to render out on the screen with either draw or update. Update right now does the same exact thing as draw, but that's okay because we're going to be using update later on. So within index.js, we can scroll down to our animation loop, right about here. And we're going to put this as the very first thing before player update and before enemy update because we want this drawn in the background, not on top of them. We're going to reference our background, and then we're going to call update on top of it, which in return is going to call draw and the draw image method. So we save that, go back over here, and refresh. You're going to see now we have a background in place. So great. That is how you want to render out a sprite, or at least a static sprite, onto your screen. So there's no better time than now to continue refactoring our code and make it as clean as possible. How would I continue to refactor this? While scrolling down, I noticed that there was a lot of code in between that wasn't really related to the actual implementation of our game, but more so just making our code cleaner. Specifically, these functions right here, such as decrease timer, determine winner, rectangular collision, those are more utility functions rather than stuff that's actually directly related to our game. As a result, I think it makes sense to put these in their own separate file, so I'm going to grab all these functions and their associated lets and consts, and then I'm going to save it. I'm going to keep decrease timer in here because that is part of implementation. It helps make our game actually function, but once I cut those functions out, I want to go ahead and create a new file. So I'm going to go to File, New File, and I'm going to paste these on in. So once I paste these in, I can hit Command S, and then I'm going to save these inside of our JS folder, and I'm going to call this utils.js for utilities. So I'm going to save that. And once I save this, I just need to make sure that I put it within index.html so that all these functions that we created are still available to us. And we know that this should come after js/classes.js, but before index.js because they're really only used within index.js in the first place, not so much within classes. And I'm actually going to go ahead and put this before both of these because even though utils.js only has functions that is used within index.js right now, maybe we'll use these later on for classes.js, but even though it's not required at the moment, we're kind of just preparing for the future right here. So we just want to make sure that we save all these files and then refresh. Everything still works and functions the same. So great, but our code is a lot cleaner within index.js for sure. So we have our background sprite in place, but what else would we want to do here? Well, it looks like our background right here has a ground for us, and our player and our enemy are currently at the bottom of our canvas. Let's go ahead and make him stand on this actual ground. How would we go ahead and do that? Well, we're going to go ahead and fake it essentially. We're just going to say that we want our player and our enemy to fall as long as they are above 200 pixels from the bottom of our canvas, rather than the bottom of the canvas directly. So we want to go into classes.js, specifically our fighter class, because we know within here, within update, this is where our fighters are affected by gravity. We're saying we want our fighters to continue falling as long as their position plus velocity are greater than our canvas height right here. So this right here is determining when should our fighters stop moving, when should they hit the ground. It's going to be this value right here that determines that. So we're saying right now they should hit the ground when they reach a value of canvas height, which is right here at the very bottom. But what if we go ahead and subtract something like 200 from our canvas height? Maybe we can go ahead and get them to stop right about here. So if we go ahead and do that from this location within classes.js, we save canvas.height minus 200 and refresh over here. You're going to see that it's 200 pixels from the bottom of our canvas. So obviously that's way too high up. Let's go ahead and decrease that, do something like 100. We're just going to eye this until we get this perfect. And that is definitely a lot closer, but if you look really closely, you can see there's still a little bit of space right there. So we can go ahead and get rid of that by subtracting a smaller value, like something like 97. We'll save that and refresh. And I think that is directly touching the floor. Maybe one more pixel, 96. And yeah, I think that looks pretty good. We're definitely on the ground right there. It looks like we're actually traveling across this background we created, which is really freaking cool in my opinion. So that's going to go ahead and allow us to check off background sprite. Now we can go ahead and do the shop sprite with animation. So what does this mean? Well, if we look within our Finder, specifically within our image folder, we're going to see that we have a shop.png, and this is what it looks like. If I go ahead and bring this up, you're going to see that it contains multiple instances of basically the same image. The only difference is going to be, well, if you look at the smokestacks, you're going to notice that it's different for each frame that we go through. And if we go ahead and loop through these frames continuously, it's going to give off the effect of animation. That's kind of how video in general works, actually, is we just go through a bunch of frames, and as we overlap these frames on top of each other, we create some sort of movement effect. So we're going to use this shop to create an animation, and we're going to place this shop right here with this empty area. I used the asset pack to create this background, and I left this open space, specifically so we could put the shop right here and create some sort of cool background animation. So the first thing we're going to want to do is simply place the shop right here, and we're going to show all frames of the image, and then we're going to go ahead and animate it from there. So let's go ahead and get our shop placed right about here. So to get our shop.png rendered out into our game, we can go inside of index.js, and we want to find where we created our background. Essentially, we're just going to create a new sprite, and what we can do is we can simply copy this constant background with new sprite, paste it down below, and say this is going to be our shop. It's equal to a new sprite. We're going to start it off at a position of 0, 0. Let's just do that to start to get it rendered out on the screen, and then our image source is going to be image/shop.png. So now that we have this created, we want to go on down. And where do we want to render this in relation to everything else? Well, it makes sense to render this after our background, but before our player and our enemies. We're just rendering these out in layers on top of each other. So we're going to reference shop.update, save that, and then we can go back to our game and refresh. You're going to notice this is where our shop is on the screen. So now we need to do two things. The shop is pretty small at the moment, so what we want to do is scale it up so it fits in this large area right here. And once it's scaled up, we just want to make sure that we place it in the exact location. So how do we go ahead and scale this image up? Well, we need to focus on our sprite class within classes.js. So if we go ahead and add some arguments on a c.drawImage, we're going to add a fourth argument right here. This is going to be the width of the image. So if I go ahead and make this something like 300, I'm going to add in a fifth argument. This is going to be the height of image. I'm going to make this something like, let's just say 200. If I go ahead and save this right here and refresh, you're going to notice both our background image and our shop right here change to that exact dimension. So we don't want to add a static value within our sprite class because we know our background is not going to have the same dimensions as our shop. We want to make sure that these right here are determined by the image we're actually pulling in using image source and this HTML image object. So to do that, instead of referencing 300 right here, we're going to reference this .image .width. Simple enough, right? And then for our height, we're going to reference this .image .height. So let's go ahead and save this and refresh, and you'll see that takes care of things in regards to the width. But now that we have this width and height listed out right here for c.drawImage, we can go ahead and multiply this by some value to scale it up. So within our sprite class, we're going to add a new property called this.scale. And this is going to vary based on the sprite that we're currently using, so we want to make sure that we're passing this through as a constructor. So within our constructor arguments, I'm going to add in scale, and say by default this should always be equal to 1, but we have the chance to change this later on if we want to. So now that we have this.scale in place, we want to go ahead and multiply this.image.width by this.scale to scale up an image. Same thing with height, just multiply it by that scale. So this isn't going to do anything by default. If we refresh, everything looks the same, but it gives us the ability to increase this number right here to something like 2. And it's going to increase the sizes of our images, as you can see. But we only want to increase the size of our shop, so we want to make sure scale is always by default 1. And then within index.js, we can find where we created our shop, which is going to be right here. We can say that our shop is going to have a separate scale from our background by assigning a scale property equal to something like 1.5. Let's go and see what that looks like. Let's save that and refresh, and now you see our shop is a little bigger. Maybe we can make this even larger. Let's go ahead and up to 2 for our shop. Save that and then refresh. And you'll see that looks pretty good, but I think we can make it even bigger. Let's go on up to 2.75. Save that and refresh. So you see this definitely loses some clarity, but I think for our game it's okay because it definitely has a pixel art style. Showing some pixelation is definitely okay, at least in my case. So we're going to go ahead and say this is going to be the size of our shop. Now we want to make sure that one frame of the shop fits right over here. So we're going to go back to our shop, or at least where we're creating it, and where do we want to position this? Well, let's just start guessing. We're going to put in 300 for X, save and refresh. Moving a little closer, maybe we want to double that, up to 600, save and refresh. That seems to be in a pretty good spot. I'm going to go ahead and keep that for now. Let's go ahead and focus on the Y-axis. Let's put 300 for Y, so 300 pixels from the top. That seems to be way too much, obviously, so we're going to go to 100. Getting a little closer, let's go ahead and add 20 to 100, so 120. And now let's start adding smaller numbers, such as 5. And it looks like we just need like 2 to 3 more pixels, so I'm going to put 128 right there. And that seems to be in a pretty good spot for our shop. So now that this is relatively within the right place, we want to begin animating this. And animating sprites can be a little tricky at first, but once you get the basic concepts, it's going to be a cinch. So basically, to get this animated, what we're going to do is, we have our whole image rendered out currently, and that's totally okay. We're going to keep this rendered out, but what we're going to do is, we're going to crop this, so that we only show one frame at a time. So when we crop this, we're only showing this first image. And then what we're going to do is, over time, we're going to animate this, so our crop location starts moving through these images. So we're going to say shift this over one frame to the right, and then render out this version. Then eventually, we're going to shift it over to another one, and then another one, and then another until we get to the very end, and then we're going to shift back to the beginning. And over time, as we do this, we're going to create the illusion as if the shop is actually animating and any other sprites that we might use within our game. But that's basically the gist of it. We want to go ahead and crop this whole image down to this little square right here, and then we're going to go ahead and push this crop through the whole thing to create the illusion of animation. So to create this crop, we're going to go over to our Sprite class, and we're going to focus in on c.drawImage. So we want to go ahead and crop this. Well, we need to change up the arguments a little bit. It's a little confusing with Canvas, unfortunately, but it's nothing we can't deal with. So the crop location is actually going to be these first 4 arguments. And these 4 arguments that are here currently are going to be pushed down by 4 arguments. So these still remain the same. This is going to be the X and Y position of our image, and also the width and height of the overall image. But if we want to go ahead and crop this, we need to add in 4 more arguments before these. I don't know why Canvas does it this way, but it does. So the second argument now is going to be the crop location. So where do we want this crop mark to start? We want it to start at 0, 0 from our image because that's going to be right about here. And then we're going to determine its width and height to only cover just one of these shop images. So X is going to be 0. Y is going to be 0. That's going to start our crop mark at the top left-hand corner. What is our width going to be? Well, we can base this off of this .image.width. We want to go ahead and grab this, paste it in right here. We know that our crop height should be this .image.height. We want to make sure we add a comma to the end of that, but this is what our crop code is going to look like. Now, when we're cropping our image by its image width and image height, the full width of our image right now is this entire thing. So we don't want to crop it by the entire thing. We only want to crop it by this small section right here. So if we get the entire image width, which is going to be from here to here, and we divide it by the amount of frames within the image, so 1, 2, 3, 4, 5, 6, we're going to get the exact width of just one of these frames. So let's go ahead and do that. Over in Sublime Text, we're going to divide our image width by 6, specifically for our shop. Save that, and refresh. And that's going to initiate the crop, but you'll see everything is just completely stretched out. That is obviously not what we want. Why is it being stretched out? Well, if we look back at our code over here, this line right here is going to determine the actual width of our image. So if we're grabbing this by getting this.image.width, we're saying the full width of our image should still be the size of this, even though we just cropped it down. So we want to make sure that this is also dependent on the amount of frames within the actual image. So I'm going to divide this by 6 as well. I'm going to make sure that we do this first before multiplying it by scale. And if we save that and refresh, you're going to see now our shop looks pretty perfect. That is cropped perfectly. So you want to go ahead and crop an image. You need to make sure that you set the crop location, the crop width, and the crop height. This is also going to be dependent on the amount of frames within the actual image. And then down here, you want to say, well, what width and height should the image actually be? Well, it's going to be the image width divided by the amount of frames times the scale. So that's how you're going to do it. But you're going to notice that affects our background image as well. Now our background image is 1/6 the size of its full width. So if we want these two to work nicely together, what we need to do is edit this. So the 6 right here, the amount of frames within our image, is variable rather than just always being 6. So what I'm going to do is I'm going to create a new property for our sprites, and this is going to be called frames max. So what is the max amount of frames that we have within our image? And this is going to be variable, so we want to make sure that we pass it through as a constructor argument. So right here I'm going to say frames max can be passed through, and by default this is going to be equal to 1, which just means we have one image, such as our background image, for this sprite. So this dot frames max is going to be equal to frames max. And now, when we go ahead and divide by 6, instead, we're going to divide this by this dot frames max in both locations. So we want to go ahead and save that. And on refresh, you're going to see our background image is back to normal, but our shop is not. How annoying. But this is really easy to fix now because we set this up correctly. Now we can pass through a new frames max, specifically for our shop. So over in index.js, we want to find our shop. We're going to set the frames max equal to, well, what are the max amount of frames within our shop? We said it was 6. So we save that and refresh. Now everything is laid out correctly. We're setting ourselves up for success when we want to go ahead and animate the shop. So if we go ahead and compare this to our actual sprite sheet within Finder, we are currently at this position right here. We took our large image showing the entire thing and we sized it all the way down to this location. This is the step we're currently at. The next step is going to be actually moving this square through our entire sprite sheet. So to do this, we want to go back to classes.js. And basically what we want to do is we want to move the x-coordinate of our crop mark. So this is our x-coordinate. If I were to go ahead and change this to something like 200 and refresh, you're going to see we basically move that crop mark over to the right. But we want to go ahead and move this perfectly to give off the illusion as if the shop is actually animating rather than just shifting it to the side slowly. So how many pixels would we have to move this crop mark over by in order to get it to exact location right here? Well, we can do a little bit of math within our code to get this exact result. So we're going to go ahead and get this .image.width, and if we divide that by our frames max, well, we're going to get the exact amount of width we need to move over by. So we'll divide this by this .frames max, and if we save this and refresh, you're going to see that our shop looks the same, but I promise you the smokestack is a little different. We just moved the crop over by 1 frame and it's in the perfect location to where we're only showing one part of the image. Once again, our background image is gone. We need to take that into account based on this new code we added in for our crop mark. So the reason our background isn't showing right now is because our background image has a width of 1024. And if we divide that by 1, well, that's going to be equal to 1024. So we're saying we want to move our whole crop mark for our background image to the right by 1024 pixels. Obviously, there's nothing there for our first image because, well, there's only one specific frame for that background image. So all we need to do here to make sure that this works for both our background image and our actual shop is we need to multiply this by a current frame. So I'm going to add in here this dot frame current, and I want to make sure that these two equations over here are performed before we go ahead and multiply that by frame current. And then we need to actually create frame current up above. So here I'll say this dot frames current is equal to 0. So I just want to make sure I actually call this frames current. Sorry about that. So this is going to be equal to 0, which means now by default we're multiplying this equation over here by 0. So we're no longer moving that crop mark over for our background image. Let's save and refresh. Background image is back. This is back to its original location as well. But we're still continuing to set ourselves up for success. We're making a completely reusable sprite class for the future. So now over time, if we increase this value right here from 0 to something like 1, and we use that on our shop class, well, we're effectively moving over our crop mark by 1 frame. If we increase this by 2, we're going to be moving it over by 2 frames, and we can keep going until we hit the frames max, and that's when we're going to go back to the very beginning and re-show this animation. But if we're never increasing frames current in the first place, well, the image is going to be static, which is perfect for images like our background image. So if we go ahead and focus in on our shop, we'll just say by default, each frame is equal to 200 pixels, and that is the result of this. Right about here, that's going to be equal to 200. But if we multiply that by frames current, and the default is 0, we're going to get 0, so there is no crop. But if we go ahead and change the 0 right here to 1 instead, well now, we're going to move that crop location over by 200. So we're just going to keep moving that until frames.current is equal to frames max, which is going to be 6 or 5, I can't remember which. But once it hits that, we're going to go back to 0 and repeat the process so that our crop mark moves, well, back to 0. So to get this effect, we want to make sure that we're increasing frames current over time, which we're going to do within update. So after we call draw, we're going to add onto this .frames current 1 frame. But we only want to do this as long as frames current is less than frames max. So here we'll write if this .frames current is less than this .frames max, then we want to go ahead and call the following. But we want to add in an else statement here that says if this is not true, what do we want to do? Well, we want to set this .frames current, so the current frame, back to 0, and that's going to repeat the animation process. So let's go ahead and save this, and then refresh. And you're going to see, well, we definitely have some sort of crazy animation going on here. So one issue is our background is animating for some reason, and it seems to be flickering between the background image and black. Why is that happening? Well, frames current starts at 0, so we can actually render out our background image and set our crop X position equal to 0. But right now, our frames max for our image is 1 because we still want to make sure that we're showing that background image in the first place. So when we go ahead and run this if statement down here, frames current is equal to 0, and then frames max is equal to 1. Therefore, this is still true for our background image, which means we're adding 1 onto our frames current. Therefore, we're pushing that crop mark off of our background image, so we're showing black, and then we're going back to the background image, which is creating that flicker effect. So to fix this, we just need to make sure that we're subtracting 1 from frames max over here. Save and refresh. That fixes the background image, and now we have our animation in place for the shop. Although it is really, really fast, we want to make sure that we slow this down to create something that looks a little more realistic and a little less jank. So how do we go ahead and slow this animation down? Well, to do this, we're going to go ahead and add in 2 more properties. They're going to be this .frames.elapsed, and then this .frames hold. So this .frames elapsed is going to be how many frames have we currently elapsed over throughout our whole animation. This is just going to increase over time as our game continues to run. And then our frames hold is for how many frames should we actually go through before we change frames current, the actual animation. So by default, this is equal to 1 with our current animation because we're just looping through every frame. But if we set this to something like 10, what we're saying is for every 10th frame, we're going to loop through this animation rather than for every 1 frame. So how do we go about using this right here? Well, we know frames elapsed should be increasing over time. So within this .update, we're going to add in this .frames elapsed is going to have 1 added onto it for every iteration of update. And now that that has a value being added onto it at all times, we can say if this .frames elapsed modulo this .frames hold is equal to 0, then we want to go ahead and call the following if statements. So what does this mean right here? Well, basically what this means is take frames elapsed, divide it by frames hold, and if the remainder is 0, then we want to call the following code. That's the difference between the modulo operator and the division operator like so. But we just want to make sure we get the remainder, so we're going to go ahead and use the modulo operator. So if we go ahead and save this, and then refresh, you're going to see just by adding that in, our animation is way slowed down, and this looks way more realistic in regards to a shop animation. And you can always change the speed of this by changing your frames hold value right here. The lower it is, the faster it's going to go, so if I change frames hold to 5, save and refresh, you can see that looks even better than before. But if you want to make this super slow, you just increase this number, it can be 50. Now for every 50th frame, this is going to go. But I think it looked good at 5, so I'm going to go ahead and keep it at that. Now later on, we are going to have different frame holds for different sprites, so we're going to change this and add it into a constructor at some point, but we don't need it right now, so we'll leave it as is, and we'll head back to To-Do, and we'll check off Shop Sprite with Animation. So now we're going to go ahead and add in a sprite for our player, specifically one named Samurai Mac. So we're going to start with the idle animation for this, and this just means we're going to be standing but moving up and down to show that our character has some movement. So where did I get these sprites? Well, over on itch.io, I searched for some fighter sprites, and this is what I was able to find was Martial Hero by Lewis Mello. He supplied this sprite and the other sprite I'm going to use in this tutorial for completely free, but if you want to go ahead and donate to him, make sure you click download now, and then send him a donation. So if you want to go ahead and get the sprites for this, you can either download it here, or it's going to be within a Google Drive link. You'll see and we already pulled that into our project within the Samurai Mac folder. So we have a bunch of different sprites associated with animations related to our player right here. We have attack sprites, we have a death sprite, a fall sprite, an idle sprite, jump sprite, run sprite, take hit sprite, and so forth. You kind of get the idea. These are all the animations associated with the movement of our character. So the one we want to focus on is idle, and if we look really closely right here, you'll see this is what an idle animation looks like. We're kind of just bobbing up and down. It's actually kind of hard to see, but you'll see once we actually get this animating that our player is going to be bobbing up and down. So let's go ahead and get this into our game. So we know we already pulled Samurai Mac into our image folder earlier on, and now we have a couple of animations in which we can use. So to begin using this, we want to go ahead and extend our sprite class, because right now our fighter class does not use any images. We need to make sure that the fighter class is able to use the same code that we have up above for our sprite, but the fighter class is going to be a little different, which is why we have it in the first place. So we can go ahead and call things like attack and different update functions. So we want to go ahead and make sure that our fighter class can use the draw method associated with our sprite class. We can just go ahead and extend the fighter class by adding extends right here, and then declare we are extending the sprite class. So by extending this, we're going to take all the methods within Sprite and put them within our fighter class if they are not available. If they are available within our fighter class, then our methods are going to overwrite the same ones that are within Sprite. So we need to determine what do we want overwritten and what do we want to keep directly from Sprite. Well, we know our fighters are no longer going to be rectangles, unfortunately, so sad. As a result, we can go ahead and get rid of this draw method right here, and if we get rid of this within our fighter class, that means since we're extending Sprite, we're going to use the draw method up above instead. But in order to use this draw method directly within our fighter class, we need these different properties available to us. We just added a ton of properties into our Sprite class up above, such as scale, frames max. We need to make sure that these are available within our fighter class as well. So we're going to go ahead and inherit these. But before we inherit these, we need to make sure that we can pass them through within our fighter constructor. So we're going to take the properties that are not currently available within fighter. It's going to be image source, scale, and frames max. We're going to go ahead and copy these. And we're going to add them to the end of our constructor for fighter. Just paste those on in. Once you have those added in, we can go ahead and call a function called super. What does super do? Well, it simply calls the constructor of the parent. So since we know the parent of fighter is Sprite, we're going to go ahead and call this constructor right here, which sets some properties for us, such as scale, image, frames max, frames current. You get the idea. But we have to declare what properties we want set within that parent constructor. So we list them out within super, and to call the parent constructor we know it takes one argument, which is going to be an object, and here we're going to list out the properties that we want set within the parent. So what are the properties we want set? Well, let's start off with image. We want to go ahead and set that. What else do we want set? Scale, frames max, and frames current. Let's add those in. Scale, frames max, and then frames current. And then what else? We also have frames elapsed and frames hold. So we'll add those into frames elapsed, and then finally frames hold. So we know that these are going to be set with our parent constructor. Is there anything else within our properties right here that can be set by the parent? There is one. It's going to be position, because we know our parent sprite has a property of position being set right here. So what we can do is we no longer need this line of code. We can simply just put position within super instead, to say we're going to inherit that property directly from our parent sprite. So we want to go ahead and save that and refresh over here to see what things look like. We're going to refresh. Looks like our game is just broken. This is a great time to inspect our elements, go to console, and see what's going on. So right here we just have the issue of image is not defined on line 55 within classes.js. So we want to make sure within super we're not referencing image, we're referencing image source, because that is the actual property we're passing through right here in settings. So we just want to make sure we set that correctly. We save. Go back again, and we have one more issue. It just says frames current is not defined. So if we go back to our code, you're going to see that this is the issue right here. Frames current is not defined because we're trying to pass it through our parent's constructor right here, but we don't actually have anything set to that by default. Right now, frames current is being set to a static value, and if you want to call super and make it work, well, we need to make sure that 0 right here is actually set to frames current passed through as an argument right here. So we can either change this right here and add an argument to our parent class. I think that's a little overkill though. Instead, what we can do is we can just go ahead and copy anywhere where there's a static value. So these three lines right here, we're going to go ahead and copy those. And then we can get rid of these within our super method. So these three right here. Then we can paste them on in directly within our fighter class. It's all up to you on how you want to do this. It's more of a preference in my opinion rather than a strict standard. So let's save that and refresh. And things are back to normal. We have errors in here, but that is totally okay because we never actually passed through an image to our fighter objects. So that's going to be the next thing we want to do. So over in index.js, we know that we just refactored our fighters to take an image source. So I'm going to grab our shop image source and I'm going to put it in where our player is going to be created. Now I don't want the image source for our player to be shop, of course. That wouldn't make sense to have a shop as a fighter. So instead I want to go ahead and reference Samurai Mac, specifically the idle.png image. So to get that, I'm going to go inside of our image folder. I'm going to say I want to go inside of Samurai Mac, and then I want to go ahead and get idle.png. So if we look at idle.png, how many frames is this image? Well, let's go ahead and count. 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be an 8-frame image. As a result, we want to make sure that we set our frames max equal to 8 for our fighter of Samurai Mac. So let's go ahead and save that. Go back over here and refresh. You're going to see we have a fighter sprite on the screen, cropped almost perfectly because we're not showing the 8 different frames, we're only showing 1. We just need to go ahead and make him bigger, make him animate, and then I'm going to show you how to crop this perfectly so that he's touching the ground. So to make him bigger, that's going to be quite easy. All we have to do is pass through a scale property. Let's set Samurai Max scale to 2.5. Save and refresh that. And definitely bigger, but we're still falling down a little bit. And the reason we're falling down is, if we go ahead and look at this actual image, you're going to see that there is a lot of space around each instance of Samurai Mac. Each frame of this image right now is actually about this large. This means we have padding on the top, left, bottom, and right of our image. And we need it this way because later on when we go into one of our attack sprites, that attack is going to extend almost the full remaining width of the square right here. So we need this extra space. But when we have all this extra space around our sprite, well, the calculations are going to be off when we're trying to run collision detection between the bottom of our sprite right here and the actual ground on our game. So what we need to do is offset our sprite right here. So we're going to move our sprite from this location to the very top left-hand corner of where we're cropping it, and we need to define what is the width and height of one of these images to get the correct collision detection. So let's start by translating our actual image towards the top left-hand corner of our crop. To do this, we're going to head over to classes.js, and this is going to be actually within our class of sprite. We want to do it here because we might be using this not just for our fighters, but for other sprite sheets in the future. So I want to add in an offset property, and here I'm going to set this .offset equal to offset. And now that I have this offset in place, I want to go ahead and use this within c.drawImage. So all I'm going to do here is from the position in which we're actually placing our image, I'm going to subtract from this .offset.x, and I'm going to do the same thing for this .offset.y. Now right now, this .offset.x and y is equal to undefined because we never actually passed anything through our sprite constructor. As a result, if you want this equal to a default value and you don't want to go ahead and subtract something undefined from something that actually exists, we can go ahead and set offset equal to an object with an x of 0 and a y of 0 because by default images should not be offset by any value. And then finally, if we want to use this within our fighter class, we need to go ahead and take this argument, put it within our fighter class constructor, put it within super to make sure that we set that property up above, and we should be good to go with just that. So now over in index.js, we can define the offset in which we want our player moved, so we can move it to the top left-hand corner of all of that padding. So here I'm going to say that our offset is going to be equal to an object with an x and also a y. What is our x going to be? I already did the calculations on this. It's going to be 215 pixels, and then y was around 180. We're going to fine-tune this as needed. And so now we have offset being passed through. If we look within classes.js, it's being passed through right here, going into super being called above. And you'll actually notice offset's being defined twice right here within our constructor. We want to make sure that is not the case. Let's get rid of this first offset. Make sure that we only have one that's set to a default right here. And then we're going to save. And on refresh, you'll see this is looking a lot better. So we essentially got rid of that padding on the left-hand side. That's fine to start. Let's go ahead and make sure that we get rid of more padding on the bottom right here. So to get rid of that padding, we want to decrease our offset value right here. Let's go to 170. That should reduce us by 10 pixels on the bottom. Looks like we're getting a little closer. Let's go down to 160, save, and then refresh. And then let's subtract about 3 pixels from that. So 157 Save and refresh that. And now we are touching the floor, so perfect. Now let's go ahead and get our sprite moving up and down. Why is this not moving up and down currently? Well, within classes.js, if we go ahead and look within update, we don't have any code responsible for moving frames elapsed or frames current through their iterations. We need to make sure that's happening in order for our draw method right here to go through our sprite sheets correctly. So how do we go ahead and add this code up above with an update into the update function down below? Well, what we could do is we can simply just copy all this code right here and then paste it into update like so, save and refresh. And you're going to see now we have that perfect animation in place. That's totally fine. Well, the only issue is we repeated our code. If we're trying to follow do not repeat yourself principles, well, it makes sense to put this in its own method rather than just duplicate it in two places. So rather than duplicate it right here, I'm going to delete that. And then up above in Sprite, I'm going to add in a new method called animate frames, because that is exactly what this function does. If I go ahead and paste this code in there, well, now in update, I don't even need to call all this code. I can simply call the method animate frame. Should actually be animate frames. I missed the S right there. We're going to call animate frames right here, which calls this in return. And now that this is within the parent class of Sprite, I can go ahead and use this method within the child class down here. I don't even need to define it. I can just call right within the update function this .animate frames, and it should still work accordingly. So let's save that and refresh, and that still works. We have clean code because we're using do not repeat yourself principles. Now, one issue is, well, if we try moving this character with WASD, we're not able to move, and if we inspect the element and go into console, well, we're getting a bunch of red errors regarding classes.js in line 23. We're not able to draw some sort of image. Do you know what image that is? Well, it's going to be our player 2 over here. We never actually set an image for player 2, and that's okay because we're not ready to do that. But we do want to make sure we're not getting that error so we can make sure that our game functions accordingly for what we have right now. So to make sure that our player is not being rendered out on the screen, we're going to go down to animate, and we're simply going to comment out enemy.update. So we do that, save and refresh, and then start moving. Well, now we can move again, and if we right click and inspect element, we no longer get any errors within our console because we just commented out our enemy, and since our enemy did not have an image source associated with it, it was just trying to error out continuously. So that's going to allow us to check off the idle animation for our player sprite. So next up, we're going to go ahead and implement our run sprite. We want to be able to switch between being idle and then running back and forth. So how do we go about implementing this sprite right here, where we're going to be using a running animation? Well, we're going to want to start off in classes.js, and we want to find our fighter class. So we're going to be adding a property within our constructor right here, and this is going to be called Sprite. Essentially, this is going to be an object that contains all the sprites for our specific fighter. So since we're putting sprites right here, now we can go ahead and use it as a property within the constructor, saying this.sprites is equal to the sprites that we actually passed through. So let's go ahead and save this, and then go to index.js so we can actually begin passing these sprites through into our fighter class. So we're going to focus on passing these through into our player. Right beneath offset, we'll go ahead and add a sprites property, and this is going to be equal to an object. So what kind of sprites is our player going to have? Well, right now we have an idle sprite, and we also want to have a run sprite, so we're going to list those out right here. Let's start with idle. This is going to be equal to an object, and it's going to have an image source, and that is going to be equal to the same image source we used prior, so this one right here. And this is also going to have a frames max associated with it. This has 8 frames associated with that idle.png sprite. And then we want to go ahead and do the same thing, not just for idle, but for run as well. So I'm going to go ahead and copy that property, paste it below, and change idle to run. Now what is the image source of run right here? Well, it's going to be samurai mac and run. So we want to go ahead and change idle right here to run to reference the correct image. And how many frames is run PNG going to be? Well, we can go ahead and open this and count. 1, 2, 3, 4, 5, 6, 7, 8. So lucky for us, this is the same amount of frames as our idle PNG sprite, so we don't actually have to change anything for frames max right here. So how this is going to work is we're going to switch between these sprites by setting this .image to whatever sprite we want to go to. So where is this .image? Well, it's within our parent class up above. You'll see we are setting an image equal to a new image based on the image source. In order to switch between these sprites, we need to make sure that we create a new JavaScript image based on those sprites, and then switch this .image to the new image we just created. Sounds a little confusing, but let's go ahead and do this within class of fighter. So we just passed our sprites through. They're now equal to this .sprite. Well, we need to go ahead and create that JavaScript object for each object within this main sprites object. So we're going to go ahead and loop through our sprites object by saying for sprite in sprites. So what is this going to do? Well, if we look within index.js, this is what sprites looks like. And basically we're just going to be looping through each object within the object of sprites. So first we're going to loop through idle, and then we're going to loop through run. That's all this means within classes.js when we use syntax like this. Now our goal here is to essentially create an image property dynamically that is going to be equal to a new image object. We're going to go ahead and do that as we loop through sprites over here within classes.js. So to add on a property to this object we're currently looping over, we can go ahead and select our main sprites object, and then we're going to reference which object we want to grab with sprite right here. So sprite right here is actually going to be the object key. So when we reference sprite, we're actually referencing either idle or run. That is the key of the object. So when we go ahead and use this syntax right here, we're basically saying this is the object we're currently looping over. And if we want to add a property onto this, we can simply type dot and then say what property do we want to add. Well, we want to add an image property, and this is going to be equal to a new JavaScript image object. So now that we have this, we want to go ahead and set the source of this right here. So we're going to paste this below and say that the source of this image is going to be equal to what? Well, we can go ahead and grab sprites bracket sprite, and then say that the source of this should be image src, and make sure that S is capital. So let's go ahead and save this, and at the very end, I want to go ahead and copy this .sprites, and looking at this, well, let's go ahead and make sure we're referencing this .sprites right here within our for loop. So we're going to loop through this .sprites, get the individual sprite, and then set everything we need down here, and then finally we're going to log this out. And before we save and refresh this, just make sure that you declare sprite right here as a const, because sprite is never actually going to change. You need to make sure that you declare this as a const, var, or let when you're looping through this for the syntax to work. So we're going to go ahead and save that, go over here and refresh, and then open up our console to see exactly what we're console logging out. So right now, it looks like we're console logging out this object. We'll open it, and now we have an idle object and a run object. And you'll see right now we have an image set to a JavaScript image for both idle and run. So technically we should be able to use this and switch back and forth between these two different actions within our fighter sprite. Now let's delete this console log and think to ourselves, what is going to determine when we switch between either our running sprite or our idle sprite? Well, we're going to determine that within index.js, specifically within our animation loop. Because we know whenever we press A or whenever we press D, we want to go ahead and run rather than idle. So since we just set up everything within classes.js, whenever we move to the left, what do we want to do? Well, we can select our player.image, and we're going to set our player image equal to our player sprites, specifically the sprite of run, and we want to go ahead and grab that exact JavaScript image. So on top of this, we need a reference.image, and with that, when we press A, we should switch over to the running sprite. Let's save this, make sure you have classes.js saved as well, refresh, and then when we go ahead and hit A, you're going to see now we have a running sprite, and I can go ahead and move back and forth because we're not switching back to idle when we let go of it, so technically this works whenever we hold down D or A. But you can see this is what the sprite looks like, and since this is 8 frames, it just works right out of the box. Not too much extra we have to do right there. But we do know we want to go back to an idle state when no keys are being pressed. So what we can do is, right above player movement, we can grab this line of code where we're setting our player image. And what we're going to do is say that our default player image is going to be equal to player.sprite.idle.image instead of run.image. So now, if we save and refresh that, we're going to idle. And then if I move to the left, we'll go into a running animation. As soon as I let go, we're going to go back to idle because we're setting that for every frame we go into. But now, if I hold down left, we're only in running. If I come back over here, you'll see we go back to idle. So that's how we're going to be switching back and forth between these to start. But we do want to make sure that we're running to the right whenever we hold down D as well. So let's go ahead and make sure that we switch our player image whenever we hold down D2. So I'm going to go ahead and paste that on in there. Then we can save that and refresh and then hold down D. And now we're running to the right whenever we hold down D, running to the left when we hold down A, and then when we stop, we're going to go back to that idle animation. So now we can go ahead and check off run. So now we're going to go ahead and switch to a jump animation. How do we go about doing that? Well, we want to go ahead and within our player const, we want to add in a new sprite into our sprites object. So to do this really quick, I'm going to go ahead and copy run, and then add a comma at the end of run, paste that on in, and then I can call this our jump sprite right here. So I just need to make sure I'm referencing our jump image right there. So instead of run, I'll call jump, and I need to see how many frames does this jump image actually consist of. So if I look within jump.png, that's actually going to be 2 frames. It's going to be our first frame switch within our sprite switching right here. So I'm going to change frames max equal to 2. And now what I need to do is determine where do we want to switch to a jump animation. So I think it makes sense to switch to a jump animation within our animation loop when our velocity is less than 0, because that means we are currently going upwards in the air. And when we're going upwards in the air, well, it makes sense to switch to a jump animation. So where are we going up in the air within our animation loop? Well, we don't really have anything directly in our animation loop, so we need to make sure we add that. Right beneath player movement, I'm going to add in an if statement that says, for player dot velocity on the y-axis is less than 0. This means we're currently up in the air. So if this is the case, we can go ahead and select our player image and set this equal to our player sprites jump image, and that's going to go ahead and switch us on over there. But if we save and then refresh and try jumping, you're going to notice, well, that looks very weird, not very good. Because whenever we go ahead and jump, we need to make sure that we're also switching our player dot frames max equal to our player sprites jump frames max. Basically, we're just setting this equal to 2 frames, because if we try using our sprite sheet animation logic with a frame rate that is greater than the actual sprite sheet, well, it's just not going to work. We're going to get this effect we're getting over here where we don't actually see the image in place. So we want to make sure that we switch that on over to 2, but we're not done just yet. You'll notice if I save this, refresh, and try jumping, well, we have a jump animation in place when we go up, but then we get some sort of weird effect where we get a duplicate of our player, and it looks like, honestly, they are teabagging the ground. Not very good for what we are going for. So one of the reasons this is occurring is because our frames max right here is now set equal to 2. We're trying to set our player image equal to our idle and our run image when those have 8 frames associated with them. But right now, we're saying that our frames max is equal to 2, so we're just running that animation really quickly. And it throws off the whole width calculation that actually keeps our crop mark in the correct place. So we want to make sure that when we go ahead and set player image equal to something like idle or run, that we also set the frames max back to those original values as well. And we only want to do it once too, because it's kind of inefficient to be setting this for every frame when we're in the air, when we really only need to set this stuff once for that action. So with all that in mind, if we look at this code is kind of getting hard to read and understand just at first glance. So this is a case in which we want to go ahead and abstract this. To abstract this, I'm going to go inside of classes.js and I'm going to add onto our fighter class. What am I going to add? Well, I'm going to add a method called switch sprite. This method is going to be responsible for switching between our different sprites. It's going to take an argument, which sprite do we want to switch to, and then I'm going to add a switch case statement that switches out the sprite we're passing through, and then finds a case as something along the lines of idle. Add a break statement for that. We're going to add in a case of run, break there, and then add in a case of jump as well. We want to break at the end of this too. So now when we call switch sprite, we want to do all that setting code that we currently have within our animation loop, and we're going to detect within here to make sure that we only do it exactly once for each action we take. So let's start off with our case of idle. Within index.js, we know we switch over to our idle state with this line right here, where we set player image equal to .sprites.idle.image. Let's go ahead and cut this out from here, and instead, let's go ahead and select player.switch sprite. What sprite do we want to switch to? Well, we want to switch to a sprite of idle. So now that we're calling this within classes.js, essentially we're going to run whatever code is within this case statement right here. I want to paste in that line we just cut out. And we can't really reference player because that is an instance of the class. Instead, we need to make sure we're referencing this.image and this.sprites. So this is the exact same thing as we had before, except we're going to call .switchSprite. Makes a little more sense, it's a little easier to read. But within classes.js, what we can do is, within a case of idle, we can add an if statement that says if this.image is not equal to this.sprites.idle.image, then we want to switch our image to idle. We're only going to do it once with this if statement. As soon as this is set, This will no longer be called, but we're still going to be running the case statement within our animation loop, but we're only switching over to that sprite sheet just once now. So let's go ahead and refactor run. We're going to go into index.js, and where are we setting our player image equal to our run sprite? It's going to be right here. So I'm going to cut this out, and then I'm going to call player.switchSprite equal to run instead. So let's save that, go back to classes.js, and then within our case of run, I can write an if statement that says, if this.image is not equal to this.sprite.run.image, then I want to go ahead and set this.image equal to our run sprite. So we can save that, go back to index.js, and then we want to go ahead and call this right here as well, because this is just basically duplicate code. Let's paste that on in there. And now finally, we want to do the same thing for when we are jumping up in the air for our jump sprite. We're going to go ahead and cut these two lines out right here. Select our player.switchSprite method, and then call jump on that. So now that we're calling switchSpriteJump in classes.js, we're going to run whatever is within this jump case right here. We're going to paste in that code and say, instead of player for these 4 instances, we're going to reference this. So we're switching our image over to our jump image, and then we're setting our frames max equals to the jump sprite's frames max, which is going to be 2. So we want to go ahead and make sure that we're setting this frames max within each if statement right here for run and idle. So if we're going to use more than one line within an if statement, we need to make sure it has brackets. And then we can go ahead and set this .frames max equal to that sprite's action, which is going to be run. So we want to switch jump right here to run, frames max property. Then we're going to go back to 8. So let's go ahead and do the same thing for idle. We'll go ahead and take this line of code right here, add some curly brackets into this if statement, and then right beneath where we're setting our image, we'll say that our frames max is going to be equal to our sprite of idle.framesMax property. Now it's important to note within this jump case, we want to make sure we have this exact conditional within here too. So we'll add if.this.image is not equal to this.sprites.run.image. Then we want to go ahead and call the following code to set our image and our frames max just once. So before we go ahead and save this and check it out, let's go ahead and make sure that we're setting everything to the correct action. So it looks like right here for idle, we are indeed referencing all idle instances. For run, we're referencing run. We want to make sure we definitely change jump right here to run. Otherwise, we're going to have the wrong amount of frames being rendered. And then for jump, we're referencing jump. We need to change run right here to jump as well. Jump and jump. With this, we should be good to go. So make sure that all of those are correct. Save that, and then save index.js, and let's test it out. So on refresh, if we start moving, it looks like running and idle are good to go, so perfect. Now if we jump, if I hit W, we do have a pretty good jump animation, but you might notice there's a little bit of flashing going on right there. What is that flashing? Why is it happening? Well, what's happening here is during our run animation, we're going to go from 1 to 2, then to 2 to 3, then to 3 to 4, and we're going to keep going until we hit 8, and then we're going to go back to the beginning. But the thing is, we might leave off on our 4th frame. If we try to immediately switch to the 4th frame of our jump animation down below, well, there is no 4th frame, therefore we're going to be rendering out just a blank space, which is what's causing that flash effect to occur. We need to make sure that whenever we switch between run and jump or some other sprite, that we reset our current frame equal to no other than just 0. That means we're going to start at the beginning of our animation. So whenever we call switch sprite over in classes.js, and we actually go through the process of switching the sprite within these if statements, we want to go ahead and say that this .frames.current, so the current frame is equal to 0 when we switch to a different sprite. So let's go ahead and copy this and paste it within each case, paste it within jump as well, save that, head over here, refresh, and now when I jump, we're no longer getting that flash in place. But if we start running to the right, you're going to notice we kind of lost our running animation right here. That is because we are furiously trying to switch between our idle and run animation. We're always going to switch back to idle because this is the first thing we call, but if we go ahead and press down A or D, we're going to switch to run, which just means we're still switching back and forth between these different sprite sheets. We want to make sure that we only switch back to idle if we're not pressing down A or D. So to do that, we want to make sure this is inside of an else statement. Next says if and else if. So we'll paste in player.switchSprite to idle if we're not moving on the x-axis. So now if we save that and refresh, we look good in our idle position, and we begin running, and the running animation is back. And we can even jump. We still get that jump animation right there. So to finish off our jump animation, we want to also add a fall animation for when we're going back down. Right now, as soon as our y velocity turns positive, we switch back to our idle animation. We want to switch that over to a fall animation to give off a realistic effect. So to do this, we'll find where we're creating our player, specifically the player sprites. It's going to be right here. And I want to add into this a fall category as well. So I know I need an image source and a frames max for this. I'm going to copy these two lines, paste it into fall, and then determine what image do I want to reference for our fall sprite. It's going to be fall.png, and this is going to be 2 frames. So we'll go ahead and change jump to fall for the fall sprite, and we can keep frames max the same right here. But now that we just added in a sprite, we also need to determine what happens when we switch over to a sprite within classes.js. So we need to add in a case statement, paste this down below, and say when we have a case of fall, then we want to switch everything to the fall sprite. So all we need to change here are these 3 instances of jump. I'm going to do it at the same time with Sublime Text by selecting one instance and holding down Command D to select those 3. And I'll change jump to fall instead, which is now available to us because we added that in when we were creating our player fighter in the first place. So now we just need to determine when we call switch sprite fall. That's going to be within index.js when our y velocity is going to be positive. So right here, when we're jumping, we're going to want to add in an else if that gets our player velocity on the y-axis and say if this is greater than 0, then we know we are currently falling. So this is a perfect time to switch to not a jump sprite, but rather a fall sprite instead. So let's save that, refresh, and then when we jump, now when we fall, we have a fall sprite in place. So that's pretty cool. But you may notice when we go ahead and hit the ground, well, we switch between it looks like idle and our fall sprite really quickly. So why is that? Well, if we look within classes.js, we're going to want to focus in on our fighters update class. So this right here is our gravity function. And this is actually what's causing that error to occur. So when we look at this position y plus this dot height, we are getting the bottom of our player right here. And when we're falling down towards the ground, we're also adding on this dot velocity, which is increasing over time. So eventually this could be something pretty big, like 21 for our velocity. So if the bottom of our player plus 21, which is going to be down here, is greater than our ground, which it indeed is, then we're going to go ahead and set our velocity equal to 0. Which means next time we go through this update function, we're going to go ahead and run this if statement again. So that means the bottom of our player is going to be around here, plus this dot velocity y, and since we set our y velocity equal to 0, well, this whole statement right here might no longer be true because we're adding on such a minuscule value, even though we might be a little farther up in the air. So since this isn't true, as a result, we add gravity back onto this dot velocity dot y. What happens when we add gravity onto our y velocity? Well, we switch on over to the fall animation. So we're going from our idle animation to our fall animation, and eventually this is going to be true again, but our position is going to be low enough to the point where we're not switching between if and else if, and we go back to the idle animation fully. So I know that's a little confusing, but here's how we're going to fix it. When this is true, we're going to set our y velocity, but we're also going to set the position of the player to be in the exact location in which it can no longer move. So what I'm going to do is, beneath this, I'm going to console log out this dot position dot y. I'm going to save that and then open up our console, and then I want to refresh just to see what that is. So we want our y position to be set to around 330 for this to not fall any further without any weird velocity issues going on. So not only are we going to set our velocity y to 0, we're also going to set this dot position dot y equal to this exact value right here in which we're no longer moving up or down. It's going to be 330, so let's go ahead and set that equal to 330, and now we can go ahead and delete this console log, save, and then refresh, exit out of this, and now when we jump and hit the ground, you're going to see we no longer get that weird flash effect when we were switching between our idle and our fall sprite, because we took care of that small little gap that was appearing due to our velocity and gravity code. So now we can run, we can also jump and fall, and then we go back to an idle position no matter what we let up on. So now we can go ahead and check off jump. So now let's add in our attack animation. So to do this, we're going to go to index.js and find our player and then our sprites object. So at the very bottom right here, we want to add in a new property, and this is going to reference attack.1. So we can see right here, this is 1, 2, 3, 4, 5, 6 frames. Now within index.js, we can reference our image source, which is going to be attack1. Change our frames max equal to the max amount of frames within that sprite sheet, which is 6. We always want to make sure that we change the property name to the exact same name as we have over here. It's going to be attack 1. So now that we have attack 1 in place, we always want to go to classes.js and then add in the corresponding case statement. So at the very bottom, I'm going to copy this case right here, paste in a new one, and say for the case of attack 1, then I want to make sure that I switch our image over to not fall, but rather attack 1 for these 4 lines of code. And now when do I want to activate attack 1? Well, if we go into index.js, we want to look for our event listener where we press on the space bar. So if I scroll on down, we're going to see when we key down on space right here, we're calling player attack. That is perfect, which means within classes.js where we actually define attack, right here, we can also call this .switch sprite equal to attack 1. So we're just calling this in a different location, but this is going to activate this code right here. So if we were to save this and then refresh and then hit spacebar, well, it looks like we're trying to attack, but we're not able to fully. That is because within our animation loop, we're saying as soon as we activate the attack animation, well, go directly back to idle because we're not moving left or right and we're not jumping currently. It shouldn't really matter if we're moving, if we're jumping, or we're standing still. When we press spacebar, we only want to show that attack animation and nothing else. So basically, when we activate an attack, we want to make sure that the switch case code can no longer be called. So we're going to do this with an if statement. We're going to say if this.image is currently equal to this.sprites.attack1.image, then we're going to go ahead and return. We're not going to call any of the following code, which might switch us to a different sprite sheet. If we save this, refresh, everything still works, but as soon as we activate our attack with space, we're going to get that attack animation, and that's pretty darn cool, but you'll see my hands are up, and this just keeps going over time. What we want to do is say when this attack animation completes just once, then we're going to reactivate our sprite switching code. So we can do that by extending this conditional right here, by adding an and statement, saying if this.frames current is less than this.sprites.attack1.frames max. And we want to subtract 1 from this because frames current starts at 0 while our frames max is the actual amount of frames starting at 1. And now in all, what we're saying is if our image is the attack image and our current frame is less than the frames max of the actual sprite sheet, then we just want to return. We don't want to call any of the following code. But as soon as frames current goes above the frames max right here, then we're going to continue, allowing us to switch back to either idle, run, jump, or fall, or even attack 1 if we decide to press spacebar again. So by saving this, going back over here, and refreshing, all of our jump code, run code, idle code seems to work. If we hit space, now we're only attacking once because we added in this conditional right here. So that's how we're going to add in our animation for our attack. We're going to implement decreasing our health bar with this new animation once we get our second player in there, and if we look at to-do, we'll see that's coming up next. So we have our sprites for our player, but now it's time to bring our enemy back into the game and replace our rectangle with an actual sprite sheet. So to do this, we want to go to where we are creating our enemy. It's going to be down here on line 73 for me. And we need to add in all the properties responsible for adding sprites into our fighter. So those sprite properties are going to start at image source within our player instance right here. So we can grab everything from image source all the way down to where our sprites object ends, and we're going to copy this and paste it into our fighter instantiation. So now we want to go ahead and reference a different image, not Samurai Mac, because, well, they should be different from each other. These are different fighters. So instead of referencing Samurai Mac, we're going to go into a Kenji directory and then reference the idle image from there. So if we look at the idle image for Kenji, it's going to look like this. We're facing to the left and we only have 4 frames within the sprite sheet. So now within index.js, we can say our default frames max is going to be 4, and for our enemy, we're no longer referencing Samurai Mac, we're going to reference Kenji instead, so we're going inside of this folder. We want to make sure that we change each instance in where there's Samurai Mac to Kenji to make sure we're referencing the correct image name. So now we just need to go into each image and make sure that the frames match up with the actual image. So we know for idle, we just change this up here to have a frames max of 4. If we go ahead and check out run for Kenji as well, we have 1, 2, 3, 4, 5, 6, 7, 8. So that's going to stay the same. If we check out jump, that's 2, stay the same. And then if we fall, we also have 2, that's going to stay the same as well. And then finally, we have attack 1. This is going to be a 4-frame animation. So over in index.js, we just want to make sure we change attack 1 to have 4 frames max instead of 6. So with all this in place, back down in our animation loop, you can see we commented out enemy.update because we were getting some errors before just rendering out our rectangle, but now that we have all of our sprite animation stuff in place, we can go ahead and uncomment this out, save, and then let's refresh just to see what happens. Well, it looks like our sprite is already in the game. We're not really in the correct location because it seems the sprite is supposed to be a little taller than Samurai Mac over here. So let's go ahead and fix that now. In order to make sure that they're placed directly on top of the ground, we can go ahead and change the offset value for our fighter. So we're going to go ahead and change this Y value equal to 167 instead of 157, and that should raise us a little bit. If we refresh, we're definitely more on top of the ground now. But if I try moving our enemy with our arrow keys, you're going to see that we are stuck in this idle position no matter what I do. If we run, if we jump, even if I attack, we're not actually doing anything. So we need to go ahead and add that implementation in for our actual enemy. And it's going to be really easy since we already did this for Samurai Mac. If we scroll on down into our animation loop, we can see that this code right here all relates to Samurai Mac's sprite switching. This code right here relates to our enemy movement, but we're currently not doing any sprite switching for our enemy. All we need to do is grab one of these lines right here where we call player.switchSprite and then paste it into one of these if statements where we're holding down our arrow left or arrow right. The only difference is going to be we're no longer switching our player sprite, but rather our enemy sprite. We want to make sure we do this in both locations right here, and we're basically just replicating the code above, but for our enemy player. So if we look at Samurai Mac, we have an else statement right here for idling. We're going to add in that else statement right here. For our enemy, this is going to be Kenji. So our enemy should switch the sprite over to idle when we're not moving on the x-axis, and then we need to take into account jumping as well. I'm just going to copy these 5 to 6 lines right here, paste it beneath our enemy movement, and then say when our enemy's velocity is less than 0, meaning we are currently moving upwards, we want to switch the enemy sprite over to jump. And then finally, for our fall animation, we just want to make sure that when our enemy velocity is greater than 0, meaning that our enemy is currently falling, we're going to switch our enemy sprite over to fall. So now that's all we have to do. If we save this, go back over here and refresh, if we start running, we switch over to our running sprite for Kenji. If I jump, we have a jump sprite, and when we fall, we have a fall sprite. All that is implemented. All we have to do now is make sure that when we press down on the arrow key, that we actually launch the attack. So let's check out where we are currently attacking with Kenji. It's going to be within our event listeners on key down. This is where player 1 is attacking. This is going to be Samurai Mac. But when we arrow down, well, we're no longer using this method down here, where we're setting is attacking equal to true. We're just calling .attack on the fighter instance. So here we're going to call our enemy, and then call attack on top of that, and that's automatically going to activate attack 1. So let's go ahead and save this, refresh, and then when we hit down on our keyboard now, you're going to see now Kenji attacks. So perfect. And we can move these two independent one of another, attack at the same time. So we really have some good physics in place with sprite animations as well to make sure that our fighting game is set up for success. So with that, I'm going to go ahead and check off enemy sprite. So now we're going to go ahead and react to our sprite attacks. So thankfully we set this up a little bit when we were dealing with just rectangles, but you'll notice over here when we try attacking, well, it really only works sometimes. So we need to go ahead and edit that functionality to get our attack box in the correct location so that it's overlaid directly on top of our player's sword attack. So the first thing we're going to do here is go into classes.js, and we want to get that rectangle overlaid on top of our sword. So we want to go ahead and show that rectangle again. To do this, we can go into our fighter class, and we're going to go into our update function right here. This is what manages our attack box position on the X and Y axis currently, so it's the perfect location to actually draw this attack box back out. So right beneath where we set our attack box position, we can call c.fillRect to bring back that rectangle that was overlaid on top of our rectangles previously. So we want to create an attack box rectangle, and we can do that with this .attackbox.position.x for the x coordinate. The y coordinate is going to be this .attackbox.position.y. Our third argument is going to be this .attackbox.width, and then our fourth argument is going to be this .attackbox.height. So if we go ahead and save this, and then refresh, we're going to see our attack box is drawn back out. So right now it's way over here rather than on top of our player, because this is affected by our attack box offset. Remember, we added that in when we were still dealing with rectangles, but we went ahead and we created a new offset property, which actually determines the offset of our sprite relative to the actual image. As a result, we need to add in a new property that actually references the offset of this one attack box right here, rather than the offset of our sprite. So we're going to go back into our fighter class, and we're going to add in a new property called attack box. So this is just going to be one object, and we can go ahead and define a default right here to see what this looks like. And inside of this object, we want to add in an offset property that's going to be equal to an object. And then we also want to add in a width, which we can set to undefined by default to start. Then also a height, which we'll also set equal to undefined. We're only using this for visual purposes, so we know exactly what an attack box consists of. So we know we want to pass through a property of attack box whenever we create a fighter. But if we go ahead and pass this through, then down here where we actually define our attack box property, we want to make use of what we're passing through. So our offset for our attack box is actually going to be equal to our attack box dot offset, which is going to be this object right here. Then for our width, this is no longer going to be equal to 100 to start. It's going to be equal to our attack box dot width. And then down here for height, we're going to say our attack box height should be equal to the height we passed through our attack box object. So now that we just set this up, we need to make sure that we're actually passing through data related to our attack box for each fighter. So we're going to do that within index.js. Find our player fighter, and at the very bottom right here, beneath our sprites property, we can go ahead and add in an attack box property. And this is going to take three properties inside of it. It's going to be the offset, which is going to have an x, and also a y. I'm going to set these equal to 0 to start. We're going to have a width. Let's go ahead and say this is equal to 100. And then a height, we'll say this is equal to 50. So now we can go ahead and define a different attack box for our enemy, and we're going to do that now. We'll just copy this property right here that contains all of our attack box data, copy that, and then within our fighter, beneath our sprites object, we're going to go ahead and paste in attack box. So if we save this, and then refresh, well now this is placed in the correct location because our attack box offset is based off of what we just passed through into each individual fighter. And this will still function the same. You'll see if I go ahead and hit space to attack, well, we're only going to go ahead and subtract from our enemy health when this attack box is actually touching our enemy. So if I go ahead and move over to the right, now when I attack, it's going to decrease, but only when this is touching. So we want to set the offset for this to make sure that it covers the full width of our attack. So we're going to go ahead, move it in front of our player, and then we're going to extend the width of our attack box so that it extends all the way to where our sword ends. So to go ahead and set that, we're going to go up to where our player attacks, and we're going to focus in on the attack box property. So we know our offset should be around 100 pixels. I believe that is the width of our player. We can just go ahead and kind of guesstimate this. If we save and refresh that, that is definitely in front of our player, and I'd say that's a good location in front of our player in which this attack should actually activate. It's not too close to the player where they wouldn't actually be hit by a sword, but it is far away enough where we actually see the animation in place where someone gets hit. So I think this is an okay location. But we do want to go ahead and move this attack box down in the middle of our player. So you might be thinking, can't we just go ahead and add on 50 to Y right here, save and refresh? Well, you're going to notice this didn't actually move at all, because if we look within classes.js, we never took into account how our attack box should be affected by the offset of our attack box on the y-axis. And you can see that directly within update, specifically where we're dealing with our attack boxes right here. So for our attack box position y, we're saying we want to go ahead and offset its position by our attack box offset on the x-axis, but we never actually did that for position y right here. So we're going to add on to this attack box offset y, and that's going to go ahead and make sure our offset actually affects the attack box position on the y-axis. So we save that and refresh. Now that has moved down by 50 pixels. It looks to be in more of a correct location. So now we just want to make sure this extends the full width of this attack. So we're going to extend the width over in index.js by saying our width of our attack box should be equal to, let's go ahead and say 200 to start, refresh. And it looks to be a little too large. We'll subtract 40 or 50 from that. Let's go ahead and start with 40 by saying our width should be equal to 160. Save and refresh. And that looks to be almost perfect. So now when we move forward and we attack our enemy with our attack box over them, you're going to see health is subtracted. And when we move back, and this is not touching, nothing happens. So we just went ahead and edited our attack box to work with this animation, but you're going to notice that this health bar goes down At the very beginning of our animation, it doesn't actually go down when the sword hits the enemy. Watch again. When I hit, it immediately goes down rather than when the sword hits the enemy. So we want to go ahead and fix that. We want to say we only want this to go down when we're through the 4th or 5th frame of our actual attack animation. So where we're detecting for a collision, it's going to be down here within our animation loop. Right here, this is where we're detecting for a collision with our player. We do want to run these conditionals, but we also want to add in another condition now. This condition is going to get our player dot frames current, so the current frame we're on within this animation. We want to say we only want to go ahead and subtract from our player health if this hits the enemy when player frames current is equal to about 4, because that is going to be the exact frame in which the sword actually comes out. And we can always check this by looking in Samurai Max Attack 1. You're going to see this is going to be our 0th frame, this is going to be our 1st, 2nd, 3rd, and 4th. So our 4th frame is what we want to monitor to say this is when we should actually subtract from the health of the enemy. So with the index.js, we want to make sure player.framesCurrent is equal to 4 when we actually subtract our health. And if we save this and refresh and try attacking, well, you're going to notice this doesn't really work, unfortunately. Why is that? Well, this should be true technically, but if we look at when player is attacking over in classes.js, we're going to be setting that whenever we call this attack method right here. So we're setting this equal to true as soon as we press down on the spacebar. And then, after about 0.1 seconds, we're setting that equal to false. So we're setting this back equal to false before we even get to frame 4 within our animation, and as a result, it's causing that conditional to not fire. So to make sure this isn't set back to false immediately, we can go ahead and increase the time right here to something like a second, but that's not going to be as accurate to say when our animation actually ends. We want to make sure that we set is attacking equal to false when our animation actually completes, whether or not we hit our enemy. So we're going to go ahead and remove this set timeout right now. So now, if I go ahead and hit our enemy, you're going to see that only activates when the sword actually touches him. But now watch what happens. If I go back here and I attack, nothing happens, but if I run into our enemy without attacking, we decrease their health because is attacking is equal to true still. We want to make sure that we set that back equal to false when we miss our enemy with the attack. So we're going to do this within index.js. So this right here says when we detect for collision, but beneath it we can say if player misses, then we want to call the following conditional. We can say if our player is attacking and our player.frames.current is equal to 4, meaning we are at the end of our attack, then we're going to go ahead and set player.isAttacking back equal to false. So we're going to go ahead and do that anyways, but this is only if we're actually touching our enemy with our sword. But right here, in case we miss, then we want to set it back equal to false, so we don't accidentally subtract from the enemy's health. Let's go ahead and save that, and then refresh and test this out. So we should miss first, which we do, and then when we run into the enemy, we're no longer attacking, so we don't subtract from their health. Now if we go ahead and cover this attack box with our enemy right here, attack, you're going to see that subtracts. Go back here, attack, and run into them. No more issues regarding that. So now let's go ahead and add in the attack for player 2 over here. We want to make sure that this attack box is over our sword swing. So we're going to go back to our code and find where we are creating player 2, which is our enemy. And we want to focus in on this attack box property. So our offset for X is going to be around -100 because that's going to make sure we shift that over by the width. Save that. And that seems to be in a pretty good spot in regards to its X position, but we do want to move it down a little bit as well. So let's go ahead and say that Y is going to be down 50 pixels. Save and refresh. And now I like the looks of that. Let's go ahead and extend this so that it actually reaches the end of this white little slash. We're going to say the width for this should be equal to 150. Save and refresh that. And now since we're increasing the width right here, the offset also needs to be taken into account because objects on the canvas are drawn from the top left-hand corner, and we're kind of trying to do this in reverse for this attack box. So we're going to subtract 150 here for our offset. And now, almost there, we need to add about 10 to 15 pixels onto that width, which means we need to do it for right here in width. We'll say that's 165, but we also need to subtract 165 as well. So we go ahead and save that. And then attack, you're going to see almost there. Let's go ahead and add on 5 more pixels, and I think that should do it. So our width is going to be 170, and then our X offset is also going to be 170. So now when we save that, that pretty much reaches the end, and I think that's a good location to say this is when we should actually hit player 1. So now, if I go ahead and move over, and move that over our player, start attacking, you're going to see that decreases over time. But we had the same issue that we had with player 1. You'll see if I attack, and then just run into player 1 with this attack box, their health goes down anyways. We want to make sure we prevent that. And we're going to do that within our animation loop the same way we did it for player 1. So we want to copy this code right here, go beneath our conditional for if we actually hit player 1, which is right here, and paste that on in. But now we know we're dealing with our enemy rather than our player, so we're going to go ahead and switch all instances of player with enemy.isAttacking instead. And we want to make sure that we select the correct frame in which this attack should hit. So we can always look within Kenji.attack1, and here we're going to say, well, this should actually be frame 2, so Kenji has a little bit of an advantage because their attacks are a lot quicker. Basically, we can say Samurai Mac is going to be slower but more powerful, Kenji's going to be quicker but weaker in regards to damage. So we want to make sure within index.js that the frames current is equal to 2, that is when the enemy's sword attack is basically over. We want to do this right here, and we also want to add in this AND statement into this conditional, so that we don't just subtract from our player's health immediately, we need to wait at least 1 frame by adding in this AND statement that says enemy.framesCurrent should be equal to 2 before we actually go ahead and subtract from our player health. So we save that and refresh. Now, if I go ahead and attack over here and run into player 1, we don't subtract from their health, but if I go ahead and move this attack box over them, then attack, that's only going to go ahead and subtract on frame 2 instead. So now really the last thing we need to do is simply remove these boxes. So to remove these boxes, we can go to classes.js, and all we need to do here is find out where we actually drew them out. It's going to be this.c.fillRect. We can go ahead and say, this is where we draw the attack box. And then we don't really need this code right now, so we can go ahead and comment it out, save, refresh, and now our attacks should work and subtract as needed, but without showing that attack box. So I attack with player 1 right here, you're going to see that subtracts, and then when I attack with player 2, that subtracts as well. So we're beginning to finish up this fighting game, but using attacks with actual sprites. So now we're going to go ahead and add in a receive hit animation, snug these two in on you, both receive hit and death animation, but we want to go ahead and react whenever our player or the enemy is hit. So when we go ahead and attack, there should be some sort of reaction right here for our enemy. How are we going to go about implementing that? Well, we're going to start by heading onto where we are creating our enemy. So that's going to be right here on line 81 for me, and I know I want to add in a new sprite for this animation. So I'm going to go to the bottom of sprites right here, and I'm going to call this take hit. So this is going to be equal to an object, and this object has 2 properties, image source, and where do I want to go ahead and grab this image? Well, simply within our image directory, so img, and then I want to go ahead and say this is referencing Kenji, and I want to get this right here. It's going to be /take space hit with a lowercase h dot png. So if we look within take hit right here, you're going to see this is a 3-frame animation, and it's just Kenji reacting to getting hit going backwards. So back within index.js, we want to say that our frames max, the max amount of frames we're going to have here, is going to be equal to 3, because that's how many frames were within take hit right here. So now that we have this here within our enemy constructor, we need to go into classes.js and define a case for taking a hit. So I'm going to go ahead and copy this case right here, and right below paste in a case of take hit with a capital H, and then I want to say if our image is not currently equal to the sprite of take hit, and I want to make sure that I change out attack 1 in each location where it is currently, swap that out with take hit, then we're going to go ahead and swap that image, change its frames max, and set the frames current equal to 0. So this is going to actually give us an option to take a hit and activate that animation. But where would we actually call switch sprite to activate take hit? Well, within index.js, we want to scroll on down to our animation loop. And right where we are detecting for collision, we know that this is currently where our enemy gets hit. So we can add a comment here that says, and enemy gets hit. So within this if statement, we also want to go ahead and select our enemy. And we're going to call a new method on top of this, because although we could write the code directly in here, sometimes it's good to abstract things to make our code more readable. So we're going to say enemy.takes a hit. So take hit right here when we go ahead and collide the attack box with our enemy. Now if our enemy is going to go ahead and take a hit, well, we're going to go ahead and subtract from our enemy health. That's already happening right here. But if we want to go ahead and simplify this, we can go ahead and take out enemy health minus 20, cut that out. We're actually going to go ahead and paste it within a take hit method directly within our fighter class. So let's go to classes.js. If we scroll on up right beneath attack, we are going to add in a method of take hit. Now we can go ahead and paste in enemy.health minus equal to 20, but we can't reference enemy anymore because that actually referenced the direct object. Instead, we need to reference this fighter's health. So this will function exactly the same as we have right now when we go ahead and launch an attack. But what else do we want to do when we take a hit? We want to go ahead and switch our sprite over to take hit. So you'll notice if we go ahead and save this and refresh, and then we hit Kenji over here, well, we're not actually going back to that take hit animation, even though we are definitely calling switch sprite to take hit. Why are we not showing that animation? Well, we need to make sure that we're not reverting to this idle animation at any point in time when that take hit animation activates. We're basically going to do the same thing that we did for creating attacks. You'll notice when I jump up in the air and create an attack, when I move forward and create an attack, well, that attack animation always goes because we're overriding all the other animations available to us. When we take a hit, we also want to override those animations, so that's exactly what we're going to do. So where are we overriding those animations? It's going to be right here within switch sprite. You'll see this if statement right here is actually representative of overriding all other animations with the attack animation. So we want to do the exact same thing, not for when we attack, but rather override when fighter gets hit. So if we're not currently attacking with this right here, we can proceed onwards to this if statement where we're going to say if the current image being displayed is equal to this sprites.takehit.image, and what else if this .frames current is less than the frames associated with the sprites of take hit. We're going to get that with .sprites.takehit.frames max minus 1. It's basically the same thing we have up here. We're just using take hit instead of attack 1. We go ahead and add in this if statement. We can go ahead and return. Basically what this means is if we're not attacking but we are getting hit, we don't want to run any of the following switch case statements. We're going to go ahead and force ourselves to return if we're currently in the take hit animation, and we're only going to allow ourselves to go onwards if the current frame is greater than the max amount of frames associated with our take hit sprite. If that's the case, then we can go back to switching over to a different sprite, including back to an animation such as idle. So this should be good to go. If we go ahead and save this and refresh over here, and we try moving, well, we're not actually able to move at all. None of our keys seem to be listening. So let's go ahead and inspect our element, and we'll head over to our console, and you'll see we have an error right there that says cannot read properties of undefined reading image. Let's go ahead and click into this. Well, basically that code we just added in for that if statement is not being read. Why is that? Well, although we have a take hit sprite associated with Kenji right here, we do not have a take hit sprite associated with Samurai Mac over here on the left. So we need to make sure that we add take hit into sprites specifically for Samurai Mac. So to do this, we'll go over to index.js and find where we are creating our player, which is basically Samurai Mac. It's going to be right here on line 29 for me, and we want to head into our sprites object. We're going to be adding in a new sprite, so we can just go ahead and copy one of these properties, and then we're going to paste in a duplicate. But we don't want to create a sprite of attack 1, but rather take hit. Make sure this is spelled exactly the same as it was within our enemy, right down here, which it is. So we'll scroll on back up and say that our image source for take hit for Samurai Mac is going to be in our Samurai Mac folder. That is great. And we want to go ahead and select either take hit, white silhouette, or just take hit. Let's go ahead and look at these. If we look at take hit, you're going to notice Samurai Mac goes backwards a little bit when he gets hit. But the white silhouette, we have Samurai Mac getting this white silhouette laid on top of him. And I would actually prefer this version simply because it shows better that he has been hit. It's kind of like a hit animation where the player flashes once they've been hit. It just indicates better that they've been hit. So we want to go ahead and use this version instead of just the normal take hit PNG. So for our image source, we're going to say we want to reference inside of our Samurai Mac folder, take space hit, capital H on this one. We're going to add a space and a dash, and then another space, and then white silhouette, and I have trouble spelling that, so I'm going to need to look at it, silhouette.png. So just make sure this matches what you have over here, and then we need to determine how many frames we have in here. So we saw that had not 6 frames, but rather 4. So let's go ahead and save that, and then refresh, and now if we try to move, we're able to move once more. If I go ahead and use our spacebar, you're going to see that now we have that React animation in place for Kenji. Let's go ahead and attack Samurai Mac with Kenji instead. You're going to see we do have an issue here with Samurai Mac not reacting. Why is he not reacting? Well, because when Samurai Mac gets hit, we need to activate that take hit method. Right now that is not happening, so let's go ahead and make it happen. To do this, we're going to go scroll on down, back to our animation loop, and we'll keep on going until we find our collision detection. This is where our enemy gets hit, but right here, above this if statement, this is where our player gets hit. So we know inside of here we want to call player.takeHit. That's going to automatically subtract from our player health, so we don't need this anymore right here. And now if we save that and refresh with take hit in place and we attack Samurai Mac, you're going to see now we have that hit animation in place. Move him out a little bit so we can see it better. And that looks really cool for being attacked. So great, we have react animations for when both of our characters get attacked. So over in To Do, we can now check off the receive hit animation. So now let's go ahead and take care of the death animation that's supposed to occur when our health bar reaches 0. So the first thing we're going to do to add in any new sprite is find where we have our constructors for both our player and our enemy. We're going to do this in both spots early on just so we don't have any bugs as we proceed. So right up here on line 29, this is where we're creating our player sprite. I want to go into our sprites object and I'm going to add in a new property, and this is going to be called, let's go ahead and call this death. So this is going to be equal to an image source and a frames max. I'm going to go ahead and grab this from take hit, paste it into death. And I want to say the image source of our death is going to be for Samurai Mac, just simply death with a capital D. So instead of take hit white silhouette, we're going to go ahead and get rid of that and say we're referencing death.png. How many frames is our death? Let's go ahead and select it. It's going to be 1, 2, 3, 4, 5, 6 frames. So let's go back to index.js and change our frames max equal to 6. Now we can go ahead and take this death object, copy it from our player, go inside of Kenji's sprites object right here, and at the end of take hit, add in a comma, and then this new death object. But we know we don't want the same death for Samurai Mac. We want one that's referenced from our Kenji folder. And that's going to be death, capital D.png as well. How many frames is this? It's going to be 1, 2, 3, 4, 5, 6, 7 it looks like. So back within index.js, we can say our frames max is equal to 7 for when Kenji dies. Now whenever we add in a new sprite right here, we need to go over to classes.js and focus on our switch sprite method. We need to add in a new case, so I'm going to copy the take hit case, paste it down below, and the case of death is going to go ahead and switch our image over to the sprite of death in all these locations, and it's going to change our frames max equal to the max amount of frames associated with this death animation. So when should we actually switch to a sprite of death? Well, we can actually do this whenever we go ahead and take a hit. After we subtract 20 from our health, we can go ahead and say if this dot health is less than or equal to 0, that means we know we're dead. Well, we can go ahead and call this dot switch sprite specifically over to the death sprite. Else, we can go ahead and switch our sprite over to take hit. So we're going to go ahead and paste that within our else statement right here. Now, similar to take hit and when we actually launch an attack, we need to make sure that our death animation does not allow anything to override it. As a result, we're going to go into switch sprite, and none of these animations should run as long as our death animation is activated. We should never be able to come back to life unless we refresh the game. So in here, we're going to say if this dot image is currently equal to this dot sprites dot death dot image, then we're going to go ahead and just return. We're not allowed to run any other code. So if we go ahead and save this and refresh, we'll start beating up on Kenji over here. Eventually when he goes ahead and hits 0 for his health, you're going to see that we activate that death animation. Now it's just running over and over again because even when we hit the ground, our frame is resetting back to 0. Once it resets back to 0, well, it just runs the animation, even if the sprite sheet is currently overriding everything. So really all we need now is a property that declares our player dead, and if they are dead, well, we are not going to call what? Well, animate frames anymore, because that's what's responsible for creating this kind of movement. We don't want any more movement as soon as they hit the ground. So for our fighters, we're going to add in a new property called this dot dead. By default, it's going to be equal to false, and then what we can say is if this dot dead is not true, so we are not dead, then we want to continue animating our frames. So now we just need to determine the location in which we set this dot dead equal to true, and that's going to be down here within this if statement that we just wrote. So let's wrap this in curly brackets like so we can write multiple lines of code within this, and we want to say if this dot frames current is equal to this dot sprites dot death dot frames max -1. Then we'll set this dot dead is equal to true. Our fighter has officially died. How sad. So let's refresh, and then we're going to go ahead and beat up Kenji some more. And once he hits 0, you're going to see that death animation activates. We can still move around a little bit. That's okay for the time being. But let's go ahead and test whether or not Samurai Max death animation is in place correctly. So we're going to go ahead and beat up on him, and eventually when he hits 0, his seems to be in the correct spot too, although he can move around as well. So the last thing we'll do here for our death animation is make sure that we can't move or jump around like this even if one of our fighters is dead. And we can do that within index.js, specifically at the bottom of our file where we write out our event listeners. So within key down, we can write an if statement that says if our player is not dead, so we need to preface this with an exclamation point, then we want to be able to run the following switch case statements which activate player movement, jumps, and attacks. But if our player is dead, well, the enemy should still be able to jump around and celebrate a little bit. So we basically need to split up this switch case statement right here so that our cases for our enemy are in a separate switch case. So I'm going to go ahead and grab these last 4 case statements, and then beneath this switch, I'll add in a new one and say when event.key has the following cases, which I'm going to paste in, then we want the enemy to be able to attack and move. So if our player is not dead, we're going to go ahead and activate this switch right here. But if our enemy is not dead, prefaced by an exclamation point, then we want to be able to call the following switch case right here as well. So we'll add that in, save, go back to our game and refresh, and now we go ahead and beat up Kenji, bring him back down to 0. We can no longer move on Kenji when I'm pressing any of the arrow keys. And we can test this with Samurai Mag as well. When I go ahead and bring him back down to 0, now he falls, and I can't really move around at all pressing any of the arrow keys, but I can still move with Kenji. So with that, we can go ahead and check off our death animation. So we're going to go ahead and work on interface design and animation next. So basically what this means is we want to go ahead and make this up here, our health bar and our timer, look a lot better. Make it mesh into our game to make it seem like it's part of that rather than something that's just thrown on there. So the first thing I want to do is change this yellow to red because that is going to represent the amount of health we have left. Kind of represents blood, I would suppose. But you typically see that within fighting games is the further your health bar goes down, the more red it becomes. So let's go ahead and do that first. In order to do this, we're going to go into index.html and we're going to find where we have our player and our enemy health. Let's go ahead and start with player health first. So we know right here we have a background color of yellow. This is our background bar. We just go ahead and change this to something like red, refresh, and then we start hitting Samurai Mac. You're going to see that now that is red. That is more representative of health that is left. We need to do the same thing for Kenji's health as well though, so we'll scroll on down till we find enemy health. And wherever we have yellow, it's going to be right here. We're going to change that to red. Save and refresh that, and now when we hit Kenji, that is red as well. So that's looking great. But now I kind of want to change this blue color to something more purple, just so it meshes in with the purple that we have within our game. So if I need a good place to choose a certain color, what I like doing is I like opening up a new tab and searching for Tailwind Color Palette. So Tailwind is a CSS framework, but with it comes a lot of great color palettes that we can use within our game. So this first result right here is going to be tailwindcolor.com, and if we click on that, you're going to see that we have all these different colors that we can use within our game. So I kind of want something that's purplish. I'm going to go to indigo, and let's go ahead and choose about 400. I'm just going to click on this, and what this does is it stores a hex code to our clipboard. So where we have a background of blue for enemy health, let's get rid of that, paste it in, and that hex code is going to be 818CF8. This is just a hex code representation of that color indigo. So if we save this, go back to our game and refresh, you're going to see that now we have a indigo color bar. I think that meshes in with our background a lot better. We hit Kenji, we still have that red, so I really like where this is going. Let's go ahead and make our blue over here that indigo color as well. We're going to copy this hex code and make sure we still have it in our clipboard, and then find where we have a background of blue, specifically for our player health, and it's going to be right here. We can replace that with the hex code. Save and refresh, and that's already looking a lot better. Now this square up here takes up a lot of space, and I don't really think it makes sense to keep it red because that's really directing our eyes towards that. The timer is important, but it's not that important. It's not the main thing we should be looking at. So if we want to go ahead and detract the user's eye from this, we can go ahead and darken this to something like black or gray. We're just going to go ahead and use black here, so let's go ahead and find our timer. And where we have a background color of red, we're going to switch this over to black. So we do that, save and refresh, and now our eyes are definitely not attracted to that as much. Let's go ahead and make this smaller to further de-emphasize this location. We're going to decrease the height of this. Let's make it to around 50 pixels. And now that's even less apparent, which is great, but we can't see our timer inside of it because the timer has a text color of black as well. So on top of this same div, we'll add in a style of color. Say that our color should be equal to white. Save and refresh that, and now we can see our timer, and this is already looking much better than what we had prior. But we can still take it a step further to really give it a nice look. So I think our health bars would look good with some sort of border around them. Same thing with our timer in the middle. So if we wanted to go ahead and add a border, we would go over to our player health bar and find this parent div right here. So we're going to add in a style of border, and this is going to take the width of the border. We want to say around 4 pixels. It's going to be what kind of border do we want to use? Is it going to be solid? Is it going to be dashed? We pretty much always want to use a solid border. And then we want to go ahead and choose the color of the border. I'm going to go ahead and make this white. So if we save that and refresh, we do have a white border around this bar, but you'll see it kind of threw things off a bit. Now our red bar is below our indigo bar up here. We want to make sure that the indigo bar is always on top of this red bar. So what we can do is, for this parent div, we're currently assigning it a height of 30 pixels, but it doesn't really make sense to do that, since our child div right here already has a height of 30 pixels. This parent div is always going to be the height of whatever is inside of it, as long as it does not have a position of absolute. So we're saying that the parent div right here should be the height of this div, because it is the one div that does not contain position absolute. So we'll get rid of height 30 right here, save, and refresh, and that automatically fixes that issue. When I go ahead and hit Samurai Mac, we still get the same effect. Everything is looking great. So now let's go ahead and add a border to our timer as well. If we want to add the same border, we can simply copy that style, find our container for our timer. It's going to be right here. Paste in that same border style, save and refresh, and now that has a border as well. Let's go ahead and add a border for our enemy health bar over here. Our enemy health is right here, and we want to add this on the parent div, so we're going to add it right here at the end of our enemy health parent div. We can go ahead and save and refresh that, and we get the same issue here. Because our parent div currently has a height of 30 pixels, we're going to make our parent div's height dependent on this div right here, so we can get rid of height equal to 30 pixels. Save and refresh, and that fixes that as well. Now with our borders, it looks a little silly for us to have a border on the right side here of our health bar, when we already have a border on the left-hand side here of our timer. Instead of having two borders touch each other, let's go ahead and make sure that we only have one border there. So to do this, we're going to go ahead and find our player health, right where we added that border. Now we don't want to just say we want a border on all 4 sides, and that's what the border property does. It says add a border on the top, left, bottom, and right sides of this container. Instead, what we're going to do is say we want a border on the top. I'm going to duplicate this style. Say I also want a border on the left. I'm going to duplicate this, paste it in, and then say I want a border at the bottom as well. So now we don't have a border right property here, and that is perfect, because if we refresh, now we have only one border right here on the left-hand side of our timer. It looks a lot better. We're going to want to do the same thing for our enemy health bar over here. So let's find our enemy health bar. It's going to be down here, and we currently have one border set to all 4 sides to be 4 pixels solid and white. Let's say we only want this to apply on the border top. I'm going to copy this right here, add in a semicolon, paste it in again, say now I want this on border bottom as well. And then finally I want to add in one more border on the right side, so I add in border right, save and refresh, and now that fixes that issue right here. So this is already looking pretty great. One more thing I would want to change here is the font of this text. This is just the default font that comes with your computer at the moment, but I think it would look a lot better if we actually used some sort of 8-bit text. So how do we actually go ahead and change this to some sort of 8-bit font? Well, if I ever want some sort of free font to use on either personal or commercial projects, I like searching for Google Fonts. We're just going to go ahead and click the first result right here at fonts.google.com. So this is going to give us a list of free fonts that we can use within our project. And the font we're going to want to use is called Press Start. So if I type that up here, it's going to filter out the fonts, and this is the one we want. You'll see this is a nice 8-bit font that would be perfect for our game. So we're going to go ahead and click this. This is going to bring us inside that direct font. What we want to do is select this style right here. This is going to open up a tab on the right hand side, and what we want to do is copy these link tags right here. If I go ahead and copy all these with Command C, head back to our project, and then within index.html, scroll to the very top right above our head tag, I want to go ahead and paste these on in. And you'll see this consists of 3 link tags that reference Google Fonts, and specifically our Press Start font. So now back within Google Fonts, if we scroll down a little further on this right hand sidebar, they'll give us some CSS rules in regards to how we can use this font. So to use this, we can copy this line down here, go back to index.html and say what elements do we want to use this font within our CSS. Well, we know right here we're selecting all elements with this asterisk, so we can just go ahead and paste in font family is equal to press start 2p. And now this is going to work because we're actually pulling the font in before we actually call this style. So if we save this and then go back to our game and refresh, now we have that really cool font in place where we have that 8-bit styling. And you can see even when we get rid of Kenji or Samurai Mac, we have that font in place as well, so great. Now I think the very last thing I would do to finish up this game is add a little bit of contrast between our players in the background, because even though we do have a good amount of contrast, we can still see Kenji in front of the shop. It would make it easier to see him if we added a white overlay behind Kenji and Samurai Mac, and on top of our background layer, just so we can really see our players and not have any issue in regards to where Kenji or Samurai Mac is at any point in time. So to add that layer, we don't actually need to add in any image. We can do this directly within index.js. We're going to scroll on up to our animation loop, and we're going to find where we're currently drawing out our players. It's going to be right here for our enemy, for our player, for our shop, and for our background. So if we say, right after we update our shop, we want to call c.fillRect, specify we want this at the x-coordinate 0, the y-coordinate 0, and we want this to fill up our whole canvas with a canvas width, and a canvas height as our last argument. And right before this, we declare a c.fillStyle equal to RGBA, and specify that our red is going to be 255, our green is going to be 255, and that our blue is going to be 255. This last value right here is going to be the alpha value. So if we use 255 for all 3 colors right here, red, green, and blue, that's going to give us a color of white. That's how colors work. If we mix those 3 together, at full strength, it's going to give us a color of white. But for this last value of alpha, this is going to determine the opacity of this white. So if we bring this down to something like 0.1, save and then refresh, you're going to see that our background just faded out a bit with that white overlay on top of it. And it becomes even more apparent if we increase this alpha value to something like 0.7, save and refresh. Now we really have that white opacity in place, and we really see our players, but it just looks kind of silly at this point to go this drastic. So I think a good medium for this game is going to be 0.15. Save and refresh that. So now we do have a white overlay, but it helps our player contrast from things like the shop a bit better than it was prior. So I think this is a good addition to our game to really make sure that we can see our players overlaid on top of this background with colors that might not contrast as well together. Now, the very last thing I want to do here, to add a little more pizzazz to the game, is that when Samurai Mac or Kenji attack each other, I want this health bar to animate downwards rather than it being so drastic and sudden. So to get this to animate, we're going to do one more Google search, and this is going to be a Google search for GSAP CDN. So GSAP is an animation library. It's pretty much the go-to for any project on the web. And we want to go ahead and click cdnjs.com. This is pretty much always available to us. And a CDN is just a link that we can grab from the internet and directly insert that library into our game. It's super easy to do, which is why we're doing it. So we want to make sure that our version right here is 3.9.1. We're going to grab this first link by clicking on copy script tag right here. So we'll click on that. And then if we want to import this, we'll head on over to index.html. We don't want to insert this within our head tag because typically scripts go at the bottom of your file. So we can say right above our custom scripts, we want to paste in that script we copied. And by doing that, we're going to import GSAP into our project. So to make use of GSAP, we want to find where we are actually decreasing this health bar right here. And it's going to be within index.js where we are selecting a specific element. So you'll see this is where we're selecting that with document.querySelector for our enemy health. We're not going to decrease our enemy health this way, but rather the GSAP way. So make sure that you have index.html saved with that new GSAP file pulled in, and once it's saved and pulled in, you can now reference it with GSAP and use a method like to. So the first argument for to is going to be the element you want to animate. What is the element we want to animate? Well, it's going to be enemy health. the same thing that we have right here. The second argument in gsap.2 is going to be, what do you actually want to animate? Well, we want to animate the width, so we're going to add in a width property right here. And to what value do we want to animate this to? Well, our new enemy health with a percentage sign. So we can copy that, paste it into gsap.2, and now we can get rid of this document.query selector, which sets our width. Let's delete that, save, and then refresh, and then when we hit Kenji, we should see this animate downwards. And now that definitely does animate downwards. It's a lot smoother than that jarring animation that we had before, but all we need to do now is make sure that it occurs whenever we hit Samurai Mac as well. We can just simply copy gsap.2 and find where we are selecting our player health. It's going to be right here. We're going to paste in what we just copied and then swap out enemy health right here for player health instead. And now we can go ahead and get rid of this document.query selector. The last thing we want to do is make sure that we're not referencing our enemy health, but rather our player health instead. Save and refresh that, and now when we hit Samurai Mac, that animates downward as well. It's really that simple when we use something like GSAP. So I think with this, we have a complete game in which we have two characters that can jump around, attack each other, and then get their health bars down to 0, and eventually, when one hits 0, we have a winner. The first player cannot win. We can still move around, and then we can start a new game by refreshing. To take this to the next level, you'd probably want to have more characters, you'd probably want a restart button, but I think this is a really good base version of this game to show you exactly how a fighter would work with attack boxes, animations, and collisions. So with that, we're going to be able to check off interface design and animation. So the very last thing we're going to do is push our project live to the web so you and your friends can play it live. So how would I go about doing this? Well, we're going to go ahead and use a platform called Netlify simply because we can push it up to the web for free under one of their unique URLs. So to begin doing this, we do need to know a little bit about GitHub, so I do recommend watching some sort of basic GitHub video, but I'm still going to walk you through the entire process. So we need to go ahead and create a Git repo. To do this, we're going to go on over to github.com, and once you're here, you want to make sure that you have an account and that you are logged in. And as soon as you log in, you're going to be redirected to a dashboard like this. You can go ahead and hit New to create a new repository, which is basically a new folder in which your game exists. It's just going to be stored within GitHub on the web. So once you're here, you want to create a repository name. We know our game is called Fighting-Game. We don't really need to do anything else in regards to description. We can make this a private repository, meaning no one can see our code. So let's go ahead and do that. And then if we scroll down, we want to make sure that we can create a repository. And sometimes we just need to make sure that we reselect this and that GitHub knows, yes, this is available. Of course it is. And then we can go ahead and hit Create Repository. So that's going to go ahead and create the location in which we want to store our game online. And now what we need to do is activate a few commands within our terminal. So I'm going to copy these lines right here, and then I want to open up my terminal on Mac. So if you're a Windows user, you're going to open up PowerShell, and you should be presented with something similar to what we have right now. Right now we have a squiggly, which just means we're within our home directory on our computer, and this is just a one-to-one representation of our Finder. You'll see right here if I list out the contents of the squiggly, our home directory, the contents of this directory are the exact same as the contents within my home directory within Finder. These folders over here match up with the folders listed out within this directory. So we want to change our directory within Terminal to where we have our game. And we can do this pretty easily. We want to search for our game within Finder. I'm going to go to Web and then find Fighting Game right here. So once we find this directory, we want to type CD into our terminal, which means change directory. And then what we can do is drag this folder on top of that CD within our terminal, and this is where our game is currently located. So if we CD into this, now we are currently within our fighting game. So now what you would want to do is paste in all that code and then hit enter, and it might ask you a few prompts such as what is your GitHub username and what is your password if you just set this up. Just go ahead and enter those in. I promise it's safe, and it's going to go ahead and push that up to your Git repo. The reason I am not inserting this is because I already had Git running within our game for tutorial purposes. So if you already had Git running within your game, you just want to select these other commands. So I'm going to go ahead and grab those, paste those in, and that's going to go ahead and push everything up to GitHub. So once this finishes running, I can go back to GitHub and refresh, and you're going to see our game has officially been uploaded to GitHub. And this is really all we need to do to start getting our game live on the web. So once that's in place, we want to open up a new tab, and then we're going to go to netlify.com. So Netlify is going to host our game, and if you're new, you're going to want to sign up. It's completely free. I already have an account, so I'm going to go to login. I'm going to log in with my GitHub account. So that's going to take me to my team, which is Reservoir, and that is pretty much my company in which I manage clients. I'm going to go ahead and push this site up to this as well. I'm going to go over to the Sites tab. And once I'm here, I want to go over to Add New Site, and I'm going to import from an existing project. So whether or not you have a team already, you should eventually come to this screen, and you're going to want to go ahead and connect to your Git provider. Our Git provider is going to be GitHub, so we'll select that. And Netlify is going to ask you for authorization. So if you're not automatically redirected back, you can simply exit out of this tab, and you'll see now we are currently authorized. So I authorized all my repos to be available within Netlify, so I'm going to go ahead and search for my repos, specifically for fighting-game. You're going to see there it is. We want to go ahead and click on this, and then this is going to ask us for a few settings to get this set up and deployed. So the owner is going to be our team name, that's Reservoir, that's totally fine. Which branch do we want to deploy? Well, we only have one branch associated with our project, which is main. You don't really have to worry about this too much, just go ahead and select main right here. And then it's going to ask for build settings. So if you're using a site generator such as Vite or Webpack or something to build your project, then you would go ahead and specify where is the output directory right here. We're not really using that, so we don't really need to do anything right here. We don't need a base directory, we don't need a build command, we don't need a publish directory. We're just going to hit deploy site with all that. And that's going to begin deploying our site from GitHub. So whenever you push changes up to GitHub, Netlify is going to make note of those changes and automatically update your site on their platform. So after about a minute or two, if this is not updated automatically, you can always refresh with Command R. You're going to see as soon as I refresh, well, our site has already been deployed, and you can see a preview of it right here, so perfect. So this is the URL they gave us. We're going to go ahead and click on that, and now our site is live on the web at that exact URL. And our game works exactly as it did before, because we pushed everything up with GitHub, keeping our code the exact same. So that's pretty much all we need to do to get this live on the web. One more thing you could do to make this a little better is change this domain right here. So if we go over to domain settings, we have the ability to add in a custom domain. And a custom domain is something like chriscourses.com, that is the root domain. If you don't want to use netlify.app, you would go here and add a custom domain. But to keep this as simple as possible, we're just going to go ahead and change the subdomain name right here. I'm going to go to options, and then edit site name. So now we can edit this to something that makes more sense, such as Chris Courses Fighting Game. Obviously that's a lot easier to read than whatever nonsense they put in there by default. So now I can save this, and now when I visit Chris Courses-Fighting Game at netlify.app, I have a game in which I can play live on the web for completely free. So finally, that's going to allow us to check off pushing live. So that's going to be it for this one, folks, and I hope to see you in the next one.